Hello, good afternoon.
Good afternoon, Dr. Deshmukh.
Very good afternoon, doctor.
Give me a second just to introduce you, okay? I think we have like 1 minute to start.
Yeah. We have still 5-10 minutes time.
Yeah, I think it's around 1 minute we'll be starting. So at 12, I think. 12.
Okay.
So you can share your full screen.
Yeah, I can share my slide.
Okay. So after introducing you, I'll let you share your screen. Okay.
That's also fine.
Okay.
Here is open. Share option. Start my slide, sir.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everybody. Welcome back again with the second day from the Plant Protection Research Institute International Workshop entitled Control Strategies of Fall Armyworm Exchange of International Experiences. And today, according to the schedule, we're pleased to meet with the highly specialized people from India, USA, Kenya, and Brazil. And I think we got the chance, I think we got lucky to have the chance we meet with them. So we are glad to welcome Dr. Deshmukh, Assistant Professor at the Department of Entomology, College of Agriculture, University of Agricultural and Horticultural Sciences, India. And today he will be sharing with us his expert opinion about an overview of fall armyworm, including its distribution, biology, natural of damage symptoms, host plants, and feeding behavior. So, Dr. Deshmukh, are you ready? Are you ready? Are you hearing me? Okay, now you can full. I can't hear you, so. Are you hearing me? Okay, I think we need to unmute you. Mr. Saeed, please try to unmute him. Mr. Saeed, افتح المايك. We can't hear you, Dr. Deshmukh. Okay. أستاذ سعيد. Okay, Dr. Deshmukh, you can share your full screen, open your presentation until we get that problem with the connections. Dr. Deshmukh, I think we have a trouble with your connection. So would you please, try to disconnect and leave the meeting, then come back again? Yep. Just kindly leave the meeting, then try to rejoin. So I think the problem from your remote connection, I think so. Or maybe your mic settings or something. At the beginning, I heard you very well, so I don't know what the problem now. I can't hear you. Okay, you can type. Type at the chat again.
Yes.
Yes, I can hear you. Oh, okay.
Yeah.
Yeah.
So now you can hear, and also I shared my slide.
Yep. Sorry for that inconvenience. Okay.
It's okay.
That's fine. Go on.
Okay. So good afternoon and good morning and good evening to all the viewers. First of all, I am so much thankful to the organizers for inviting me to speak on an overview of Fall Army Band. In just another 35 to 40 minutes, I will be sharing my experience with the Fall Army Band. For the sake of convenience, my topic is divided like the introduction, the global distribution of this Fall Army Band, why we are talking much about the Fall Army Band, its life cycle, nature of damage, and which are all the host plants so far recorded in India, and which are all the natural enemies, and lastly, the conclusion. So in India, maize is one of the very important, the cereal crop, third most cereal important crop after rice and wheat, which is grown in an area of 9 million hectares with a production of 28 million tons. Up to 2018, these are all the pests, or we can say the conventional or age-old pests, which are attacking the maize crop at different the growth stages. All of a sudden, in the year 2018, this fall armyworm reported in India for the first time in Karnataka. So this fall armyworm, it is native to the America. It is having a long history. For Americans, it is having of more than 200 years of the history. And for the first time, this pest, Smith, Dr. J. Smith and Abbott, in the year 1797, they illustrated the systematic characters of this the fall armyworm, its metamorphosis, and which are all the hosts on which it's feeding. Later, the Glover in the year 1856, he documented the details about the fall armyworm, its feeding behavior, and which are all the other hosts on which it's feeding. And also he called it as a marching worms, causing huge damage in Western Florida. And he also advocated to manage this pest, collect and kill the worms, or collect and kill the worms. And Chittenden in the year 1901, he first reported the outbreak of the fall armyworm on several crops like sorghum and maize in 1899. Later, the Walton and Luginbill in the year 1917, they studied in detail about its fall armyworm and its nature of damage and how it destroyed the corn and other millet crops. And a series of outbreak of this fall armyworm reported by Luginbill in the year 1928, 1912 or 19 unusual outbreaks of this fall armyworm is noticed in USA, particularly in Florida. Then the FAW severe infestation throughout the southeast US along the Antarctic coast, which includes the Florida, then Georgia and Northern North and South Carolina. Later, Secula and Sparks, they studied the sex attractants, the pheromone-related work, and Spark, and he studied the detail about the biology of this fall armyworm, and several the symposium which took place on the fall armyworm. In the year 1992, the fall armyworm symposium was dedicated to Sir James Edward Smith, who for the first time in the year 1797, so he illustrated this fall armyworm. So coming to the why this is so important, the what are all the economic damage it causes. So if you take America, the yield loss ranged from the 40% in Central America and 72% in Argentina. If you take Brazil, they alone spends nearly 600 million US dollars for this management of this pest. Nearly 6 to 8 rounds of insecticides they are spraying for this fall armyworm management, particularly on corn. Recently, in the year 2020, the fall armyworm, the FAO, has reported that it has a very potential, the pest which can destroy up to 80 million tons of maize worth of 18 billion US dollars per year, affecting the 600 million people in Africa, Asia, and also the Near East. Coming to the Africa, particularly the Ghana and Zambia, again, they estimated the loss due to this fall armyworm, which ranged from 26% and 35% in Ghana and Zambia. And in India, the area affected in the year 2018-19, it was around 2.45 lakh hectares. In China, it was around 1.13 million hectares area affected by this fall armyworm. In Vietnam, nearly 35,000 hectares of area affected by the fall armyworm. So why this pest is called as fall armyworm? Because this pest is native to the Americas. In North America, this pest is only confined or endemic to the southern parts of Texas and Florida, which is the corn growing belt. When the winter starts, the population moves towards the central part of the North America. During the fall season or autumn season, in the month of September and October, when the crop is at the period, you will find a lot of the corn crop in the central part of Northern America, particularly the Nebraska states, Iowa states, and Minnesota states. Then this pest occurred in the fall season in a severe form. The farmers, they started calling it as a fall. So the fall armyworm, the name came as the fall armyworm. Now, fall armyworm has become a global pest. It is spreading like anything, which doesn't require any passport or visa to move from one country to other country. I already mentioned before 2016, it was confined to only the Northern America, South America, and the Canada. All of a sudden, in the year 2016, in western parts of the Africa, it was first reported in Nigeria in the year 2016, January. Then in the year 2018, it has spread to India. In 2019, Sri Lanka, and Egypt in the year 2019. And very recently in the year 2020, February, it was reported in Australia. Within a very short span of time, the pest has crossed the continents. In Africa, the corn or the maize is the staple food for the Africans. And in more than 40 countries in Africa, we can notice the fall armyworm as per the reports of the Prasanna and his associates who reported in the year 2018. And before 2018, if you look to the scenario in India, so armyworm, that is the Mythimna saprata, its outbreak was noticed in 2017 in a rampant way, not the fall armyworm, it's armyworm. In India, it is not regularly occurring on the maize or the rice. Once in 10 years or 12 years, this pest occurs, causes a severe damage to the crop. And again, in the next year, we don't know where the pest goes. But this was the situation in the year 2017. And looking to the base, the 2017, the damage, in the year 2018, we surveyed the farmers' field, and also we visited the fields. We suspected it's a fall armyworm in forest area in 2018, but it was a different pest. So we came back, and we said to the State Department of Agriculture, it is of Castor semilooper. After that, all of a sudden, we noticed a different kind of the pest on maize in our campus in May 2018. And we also received several calls from the State Department of Agriculture and other line departments. There is a pest, again, the armyworm Mythimna saprata in the year 2018. Then we surveyed the different fields, and it was not the Mythimna saprata. It looked like a different one, and we collected the larvae and started rearing under laboratory condition. So I was not noting it is having the cannibalism property. So within 4 or 5 days, the one larva which has completely eaten by the another larva, at the end, we have not got the pupae. Then we started again collecting the later instars larvae, and we started intensively collecting from the field and reared under the laboratory, and we found, and we studied its the molecular study and also the morphological study, and it is of a new invasive pest, that is of fall armyworm, that is of Spodoptera fruciperda. And also we reported for the first time in India, so presence of fall armyworm, an invasive pest on maize in University jurisdiction. And also we published our paper in Indian journal, that is first report of fall armyworm, an alien invasive pest on maize in India. And subsequently the other people from NBAR and also US Bangalore also reported. And this is the one comprehensive manual, written by Dr. B.M. Prasanna and his associates. So it includes everything about the fall armyworm. What are all the cultural practices, mechanical or physical or biological practices, which are all the insecticides we need to use, which are all the very dangerous or most toxic insecticides. Those who are working on fall armyworm, or those who want to work on fall armyworm, kindly go through this comprehensive manual. You will get all the information about the fall armyworm. So thanks to Dr. Prasanna sir, when we reported this fall armyworm for the first time in India, I contacted Dr. Prasanna sir. He gave so many the inputs how to study about this pest and how to manage this pest. And in India, when we reported this pest in May 2018 for the first time, and within a very short span of time, this pest spread to the adjoining states. Within a very short span of time, 2-3 months, then we notice this pest in the entire country except the Jammu and Kashmir. So after Kharif 2018, in Rabi planted crop, many of the frustrated farmers, they are removing the crop. In spite of the insecticides, the farmers, they removed the crop. And also we noticed its incidence of this fall armyworm on sugarcane. But the infestation, it was very, very less than 1% infestation on sugarcane. Just we reported on 3 months old crop sugarcane. Then why we talk much about the fall armyworm? What are all these important the characters or the features of this fall armyworm? So I can correlate with this pest with the Helicoverpa armigera. whatever the qualities of Helicoverpa armigera, which is having almost all the characters of this pest, the fall armyworm is having. We can notice the high fecundity, which can lay up to 1,000 eggs, which can migrate 100 kilometers per day or per night, and it is of having the facultative diapers. And also we can notice the different stages on a single crop, overlapping generations on a single crop you can notice. And also the pest will be in the whorl. Again, we need to spray the insecticide to the target site, then only it reaches to the larva. Otherwise, if you spray the insecticides on the leaf, which may not reach the insecticide to the larva, and you won't get any results, then we say the insecticide is not effective against fall armyworm. So the application method, the method of application of insecticide, it is very, very, very important one. Apart from that, this insect is having a very short life cycle, and which can complete a more number of generations in a year. And also we learned that in USA and the Brazil, it has developed resistance to many of the insecticides like organophosphates, pyrethroids, and carbamates. Because of these reasons, this fall armyworm is a very important pest, and we need to understand thoroughly about the fall armyworm. So I will just go through a little bit of its biology. The fall armyworm, it lay eggs, around 800 eggs on the upper surface of the leaf or the lower surface of the leaf in groups. The eggs which are of a dome shape, then ventrally it is a flattened one. You can see the colors of green or golden yellow or black color eggs you will notice. And you can see the egg layers one over the other. It is the base layer, then over that another layer you will find, and another, usually 2 to 3 layers you will find. You can see here. And also the incubation period is around 2 to 3 days. And the later larva which moves into the maize plants and consume the leaf tissue, excluding the veins and midrib. And coming to the larval stage, there are 6 larval instars. The early instars, they scrape the chlorophyll content, and later instars, they completely devour the leaf. And here, the 5th and 6th instar larvae are their highly voracious feeders, which can consume nearly 92 to 93% of the leaf. If larval weight, the 5th and 6th instars consume maximum as compared to the 1st, 2nd, and 3rd and 4th instar. You will come to know based on the larval stage, which are all the management practices we need to follow.
أيها السادة والسادة، نشرح الآن المراحل اليرقة. هذا جدول يوضح المراحل المختلفة ومدة وعمر كل منها.
Some people, they are using some pointers. It is of disturbing one.
البعض يبدأ مثلا بعضها يستمر من يومين إلى 3، ومن يومين، ومن 4 إلى 6 أيام. ومقابل كل منها ستجدون حضراتكم.
Okay, Dr. Deshmukh, just keep going. We're trying to solve that problem. Okay. Just keep
من
going.
فضلك يا دكتور دشمك، من فضلك دكتور دشمك، من فضلك استمر في الحديث، فنحن نتابعكم، نتابع حضرتك هنا في مصر.
Just keep going, please.
من فضلك استمر في الحديث، نحن ننصت إليكم.
Can I proceed?
نعم. هل يمكنني أن
just keep going.
نعم.
We're hearing you.
Yeah. Okay. Thank you, Professor. Then
لك سيدي الأستاذ.
in the later instar we find the cannibalism.
بالطبع فيها المراحل التالية من مراحل اليرقة، في المراحل التالية من مراحل اليرقة نجد أن
So in the later instar we find the cannibalism.
وبالطبع في المراحل التالية نجد اليرقات تختلف طبعا استهلاكها للطعام. في المرحلة الأولى التي تستمر من يومين إلى 3 نجد 2، في المرحلة الثانية 4.7، في الثالثة 16.3، في الرابعة 77.2%.
Dr. Tishmoch, I think this is the translation. So I think if you just have a second after you finish every sentence, just give us time to
من فضلك أعتقد أن هذه هي الترجمة. ممكن تقول جملة أو جملتين دكتور ميوك وتسكت حتى نتمكن من حل هذه المشكلة.
بريز دكتور شران.
دكتور شران من فضلك استمر.
You can close the chair and open it again.
ممكن.
Dr. Tishmoch, just leave the meeting, please, and just reconnect to solve the problem.
Okay.
Sorry for that. Yeah.
Okay. We can't hear you.
Yeah, we're hearing you. You still.
What I should do?
Yeah, just leave the meeting. Leave.
Okay.
Leave the
again
meeting.
I need to join?
Yes.
Okay.
أستاذ سعيد، هو كده الترجمة هتكون يعني متزامنة مع الكلام بتاعه ولا هيبقى مفصولة؟
الترجمة إن شاء الله متزامنة مع الكلام.
طيب تمام. Yep. Yeah, we can see your screen now.
Okay.
دكتور تشمخ. المايك يا أستاذ سعيد، حاول تعمل unmute للمايك بتاعك. أستاذ سعيد.
Open mic, Dr. Sharan.
Yeah. So can I start now?
Okay.
Okay, thank you. So if you look to the larval stages, there are 6 larval instars. The early instars, they scrape the chlorophyll content by on the upper surface or the lower surface of the leaf. And later instars, they feed on the entire leaf. And the 5th and 6th instars, they are voracious feeders. And they can cause a huge damage to the crop. So the management, again, it depends upon the stage of the crop, stage of the pest, whether it is of early instars or the later instars. Like Helicoverpa armigera, here also we can notice the cannibalism. So cannibalism, it is one feeding on the other one. We studied its biology when we reported this pest for the first time in the year 2018. So these are the different, the larval, the stages. You will come to know what is the size of the larva and also the weight of the larva. To the maximum extent, we can measure the larva around 430 to 500 milligrams, the last instar larva. And under field condition, you can very easily, we can identify the fall armyworm. So this is of a inverted Y-shaped head. And also on the 8th abdominal segment, dorsally, you will find the black dots. And you will also find a pale dorsal line on the larva. Please remember these 2 important the characters. One is inverted Y line on the head and also the 4 black dots in a square form. And the pupation takes place in the soil in 8 to 10 centimeter below the soil, and which is of having the facultative diapers. And you can very easily, you can differentiate the male and female, the pupae, and like any of the Lepidopteran insect pests. If you look to the distance between the female genitalia and anal slot, it is of more in case of female pupa as compared to the male pupa. Those who are studying its life table studies or the bioassay or the toxicological studies, you need to maintain the culture. So you can very easily, you can differentiate the male pupa and the female pupa. So coming to the adults, the adult moths, they are very active during the evening hours and night hours. You can also very easily differentiate the male and female one. And in case of the male, you will find the triangular, the conspicuous white, yellowish whites, the spots in the center of the forewing, whereas in case of female, you won't find any these spots. And these adults, you will find in the whorls during daytime. In the night hours, you will find their activity. And the adults live in and around 7 to 12 days. So this is the comprehensive information on the biology, the egg, neonate, then the mid-instar larva, late instar larva, pupal period, and life cycle. So it completes its life cycle in a period of 32 to 46 days. In a single, the maize crop, which can complete the 3 to 4 generations on a single maize crop. And coming to the nature of damage, so it lay eggs on the upper surface or lower or in the whorl of the maize plant leaf. Immediately after hatching, the larvae starts moving and they secrete a kind of the silken thread. Can you see? Of course, the picture is not so clear. You can see here. So it forms a balloon kind of the like structure, and which can spread to the nearby plants. So that is a kind of behavior of the fall armyworm, which are spreading nearby the plants. You will find its infestation in the early duration of the crop in patches. Later, you will find its infestation on every plant. So when the first and second instar larvae, they start feeding on the leaf, you will find a white patches on the leaf. So from a distance, you will come to know, yes, this plant is infested by the fall armyworm. And if you look to the later instar, the mid instar larva, Again, the leaf damage you will find more. And if you look to the later instar larvae, you will find a frost material on the leaf. If it is a fresh one, if it is a fresh excreta, yes, you will find the presence of larvae in the whorl. If the excreta is of dried one, you won't find the larvae inside the whorl, which might have entered into the pupal stage or attacked by any of the natural enemies. So without destroying the plant, you will come to know the presence of the larvae in the whorl or not. And in India, so its damage is more pronounced on the leaf. Mainly it is feeding on the leaf. Less than 1% its damage was noticed on the cob. We reported, but its extent of damage on the cob, it is very, very less. And apart from that, the maize crop or corn crop, in India, it was reported on green amaranth or finger millet, on many grasses, sugarcane, then banana very recently in the year 2020, but its infestation is very, very, very less. But it mainly prefers on the maize. Next one is the sorghum. Next one is the pearl millet. These three are the very important, the food plants or the host plants for fall armyworm in India. Most, it is of a preferred one. And these are some of the pictures you will find its damage on maize, sorghum, pearl millet, and even on ginger also it was reported. And the Dr. Jaba from ICRISAT, Hyderabad, India, he developed the artificial diet for rearing the fall armyworm. He evaluated the different, the food-based, like chickpea-based and sorghum-based, the diets. Among these three different diets, the sorghum plus chickpea-based diet, it's found to be very good for rearing the fall armyworm, and which is of having high fecundity and also the short life cycle. So this paper is published in Indian Journal of Entomology. So those who want, you can refer this paper. And with respect to the natural enemies in India, after the introduction in this pest introduced in 2018 up to 2020, so we reported totally 36 natural enemies, which include the parasitoids, 16 parasitoids, 14 predators, and the 6 pathogens. So these are the different, the parasitoids like Talanomus and Trichogramma, you can see in the picture, and Chilonus and Coccygidium. It is a larval parasitoid. Again, the Odontopyrus, it is also a larval parasitoid. And these two are the very important, the parasitoids, the Exorista and Campolytis chloridae. These are some of the predator insects like coccinellids, earwigs, carabid beetles, and the pentatomid bugs, particularly the Eucanthicona persulata, it is found to be very effective under field condition. Of course, it is a general predator. We got the higher population among the different predators. And also we noticed the ants feeding on the fall armyworm larva and geocorids, or which are commonly called as big-eyed bugs. And one very important, the pathogen, Metarhizium reli, the natural epizootics in the month of September and October, which has killed almost all the stages of larvae under field condition. So no one has sprayed this Metarhizium reli. Naturally, we have seen the dead larvae on the plant. So 80 to 90% high relative humidity and low temperature favors the multiplication of this, the fungal pathogen. And another one, NPB, we got the less number of the infected larvae of NPV. And we also studied the different insect pests on the maize or corn. So we studied the level of the infestation of Spodoptera frugiparda, Spodoptera litura, and Sesamia inferens, Chylopatulus, and Mythimna saprata. So if you look to the data, So the pest in the year 2018, it was less, but in the year 2019 Kharif, we found only the fall armyworm. It is due to the fall armyworm is having same feeding site as of the Sesamia inferens and also the Chilopartellus. There might be some competitive displacement. So one of our department student, the Divyas, he studied the competitive, is there any competitive displacement of this fall armyworm with the borers? And in the year 2020, you can see the infestation of the fall armyworm only. No, very negligible infestation of Sesamia inferens and also the Chilopartellus and also the Spodoptera litura. And with respect to the management of this pest, the installation of pheromone traps, it is a very important one. The use of the 2 traps per acre, we got very good number of trap catches. And also the collection and the destruction of egg masses, not removing the leaf completely. We can collect the eggs and we can destroy. Here you can see the eggs here. Just to show within a very short span of time, so as many as number of eggs we can collect. So you can squeeze the egg masses, you can destroy the egg masses. So we can reduce the pest population, because on the upper surface, more than 80% of the times it lay eggs on the upper surface of the leaf only. Very easily visible, you can destroy the egg masses. And with respect to the pest management, what is the threshold level? So we are working on this one, but we don't have the data. What is the number of larvae per plant, or what is the level of infestation when we need to take up the control measures? All such kind of studies still it's going on. So whatever the information I collected, this one, it is from Dr. Prasanna's manual. So when the crop is around 15 days old, if the 20% of the plants, you find out of 100 plants, 20% of the plants damaged by the fall armyworm, and which are of showing, so 2 to 3 scale, Davis scale, as we know, 0 to 9, it is of Davis scale. If it is of showing 2 to 3, the damage rating, then we need to go for the management strategies. If the crop is around 20 to 40 days old, the plant can withstand up to 30% the leaf damage. And these are some of the insecticides which are very commonly used in India. So neem-based insecticides and also the BT for the management of the first and second instar larvae. And we are also using one of the insecticide that is of cyanidroliniprole plus thiamethoxam. It is a seed treatment, FS formulation at the rate of 6 ml per kg of seeds. Other than that, we have the other insecticides belongs to the novel mode of action, like emamectin benzoate, 5-SG at the rate of 0.5 gram per liter. Chlorantraniliprole, another insecticide, a very good molecule, 0.4 ml per liter of water. And Spinetoram, that is of spinosyn group, that is of 0.5 ml per liter of water. For 1 hectare, usually we recommend 400 to 500 liters of water to spray. And apart from that, we also organized the workshop on creating awareness and management of this fall armyworm in 2018 and 2019 for the benefit of the agricultural department officials and also the NGO groups and also the farmers. And I also served as a resource person at Nepal. The Nepal government called to deliver a talk or to share my experience with fall armyworm in the year 2019 before COVID. And we also gave the information through the electronic media, and also we have conducted the off-campus trainings to the farmers, and also we educated the pesticide dealers, they are the primary source. From there, our information be disseminated to the needy farmers. So educating the pesticide dealers, that is very, very important one to manage this pest. And also we published the extension bulletins for the farmers and also the extension entomologists and also to the NGO groups. So this, the manual developed by ICAR, and one of my friend, Dr. Firake, he also developed the comprehensive manual on fall armyworm, its identification and management. We developed the extension bulletin on fall armyworm, which encompasses all the information. It is of 6 to 8 pages, which comprises its distribution, nature of damage, management, and the natural enemies. All that includes in this, the research bulletin. Recently, we published one book chapter published by the Springers, that is in the polyphagous pests of crops. Our chapter on fall armyworm published the co-authors like Dr. B.M. Prasanna sir, CIMIT director, my colleague Kaleshwar, and ICRISAT scientist, and also SABC director Bhagirat Chaudhary. So it includes all the information on fall armyworm and recent and updated information you will get from this book chapter. So kindly go through, it is available in the ResearchGate. And also we developed a small video clip on fall armyworm. It is of a 12 minutes video clip with respect to its global spread and its biology, how it causes the damage, and what are all the management practices so far. So recommended by the university and also the government of India. It is of the very good the video clip of 12 minutes. And also the bringing to the notice to the government or the policy makers, that is very, very, very important one. So our Honorable Vice Chancellor briefing about the fall armyworm incidents in our university jurisdiction and what are all the management practices we advocated to the farmers, because in India, the Karnataka, my university where I am working, it is of having of a maximum the maize or corn area, and bringing to the government of ECLs, it is very, very important. So that will help to make some decisions or policies. So coming to the conclusion, so fall armyworm has no boundaries, which can move to any countries, and understanding its agroecological behavior, it is very, very important one. Before managing any insect pest, understanding its biology, its nature of damage, its behavior. So all that one is very, very important for effective management, and creating awareness about this pest. In 2018, many of the farmers, they sprayed 4 to 5 rounds of insecticides in India. But in 2020, the farmers, they are using only 2 rounds of insecticides. So creating awareness about this pest is very, very important one. And since it is an invasive pest within so we need to develop the IPM based the management practices, which are based on the local agroclimatic and socioeconomic conditions of the farmers. And also there is a need on the international collaboration to manage this pest. So thank you so much for the organizers for giving me an opportunity to share my little experience with this fall armyworm. If you have any questions, please over to the organizer. Hello. Hello. Hello.
Hello. Hello.
Hello. Hello.
Yes, thank you very much for your very interesting lecture, really. I have cited your three...
Hello.
Can you exit from the presentation, please?
Exit. Thank you, Professor. Thank you.
Thank you. I have cited three of your papers. Really, they are very valuable papers. I mean, you recorded the insect in Karnataka, and then you did very interesting work on biology. And then the last paper, I think, on the biological control. And really, I have cited most of your papers. It's in a book which will be published by FAO in the coming weeks, maybe, translated into Arabic. And it was very helpful to me. And I have learned also a lot from these, articles. I'm now trying to get the book. I have already sent the request to England to get the book to see what's going on in the Karnataka and India. And do you know, do you decide from where come to Karnataka? I mean, is it from Yemen or from, I don't know from where. Do you have any genetic studies to decide from where this insect comes?
So still we don't have the concrete information from where the pest arrived to India.
Mm-hmm.
But our population, it is matching almost with the African population. But in India, whatever the strain we have, that is of corn strain only. Initially, we reported it as a R strain. Then we discussed and we worked with Dr. Nagosi, who is a well-known molecular biologist from USA, by using the different markers. We used the TPI markers. By using that one, we came to know that it is of the corn strain only. Whatever the strain which is there in India, it is of corn strain. But still, we don't know how it entered into the India. Still, it is a question mark.
Mm-hmm. I have many questions, but let's go to another. Okay. Okay. Thank you.
Thank you.
I think there's Ahmed Abdulwali. Where's the coordinator? The coordinator, where's the coordinator?
We also evaluated the different insecticides. You might have seen that paper also, the efficacy of different insecticides, and also we studied its the bioassay by using different insecticides.
I have seen it.
Yes, that also appeared in Florida Entomologist.
You mentioned the Nomeria. Is it Nomeria or Metarhizium raeli?
Yeah, earlier it was called as a Nomeria raeli. Recently, its name changed as Metarhizium raeli.
Okay.
The genus name changed now. It is of the Metarhizium raeli.
Thank you.
Thank you. So a lot of studies going on in our state, in my lab. Many of my students, they are working on this fall armyworm. So one on working on the natural enemies and the evaluation of the botanicals and biopesticides and the host preference, apart from the maize, which are all the most preferred hosts, which we can rear under laboratory condition for bioassay purpose or the life table studies. Mm-hmm. So different aspects, my students are working on this fall armyworm.
Until the coordinator come, please check the chat. I think there's many information in the chat also.
I need unmuting. Thank you. Please, we need presentation. Thank you. Can you control? Yeah, how can to control this insect biologically? So far, when you compare to the 2018, so 2019 and 20, the pest population is comparatively less because the native natural enemies so far developed in a good number, but that the number of parasitoids or the natural enemies is not sufficient to reduce the pest population. Right now in India, the majority of the farmers, they are using the insecticides. So we can use wherever there is a very low incidence, very low temperature and high relative humidity, there we can use this Metrrhizium reli. And also for the management of the early instars larvae, we can use the botanicals like neem-based insecticides, like azadirachtin we can use, and also the BT we can use for the management of the early instars.
دكتور ولاء تفضلي.
Good afternoon, everyone. Thank you, Doctor, for the nice presentation. I ask about the slides you mentioned, trap. This trap is a pheromone trap?
Yeah, exactly. It is a pheromone trap, which is attracting the male moths.
Yes. I think pheromone trap or pheromones for Spodoptera fragiberda is until now attack so many species like Lucania, like Sesamia critica. If you have a more specific pheromone, can you tell me about it?
Hello. So we have the species-specific pheromone trap and also the lure for the Spodoptera frugiperda. There are 6 or 7 companies in India. They are producing the lures against the fall armyworm, and we also seen the trap catches, whether it is of Spodoptera frugiperda only or the others one, Spodoptera litura or Sesamia inferens. But it is of Spodoptera frugiperda only. But still there is a much of the variation with respect to the number of the trap catches by using the different sources of the lures. We confirmed it is of Spodoptera frugiperda lure only. We have not got any other the moths trapped in the FAW lure by using FAW lure.
Please, can you tell us about your email to connect with you about this subject?
Pardon?
Can you write your email?
He will write his email on the chat. Okay, so you can pick it up from the chat.
Okay.
Okay, thank
Please
you
write
so
your
much.
email. Thank you.
Thank you so much.
I am the coordinator, it seems to me. Who is... Can you unmute the guys, please?
Most of the beneficial predators, gypsy moth, the forest, so predators, there's no solution. I think it is the time to stand with agroforestry. In Europe, as expected, what is the effective way to suppress managing this harmful? So this is of the armyworm or the fall armyworm. The question asked by Dr. Ahmed. In your opinion, as expected in armyworm, what is the effective way to suppress the managing this harmful pest? So other Dr. Walla, he asked, what about the biological control with insect parasites? So in India, we found the 2 important, the egg parasitoids. One is the Telenomus species and another one is the Trichogramma. And also we found the larval parasitoids like Campholytis. So these 3 are the natural enemies. So their population is comparatively high as compared to 2019. But these parasitoids, which may be used in future, we can mass multiply these natural enemies and we can release in coincidence with the egg mass when there is a egg mass in the field. So that is that we can use in future by using the natural enemies. So, and one more thing I told, this Nomoria reli or the Metrrhizium reli, this also we can use when there is a low temperature and high relative humidity. So this can be used at the rate of the 2 grams or 2 to 3 grams per liter of water.
I think Dr. Sharan, now it's 2 o'clock. Your time is almost gone. I don't know where is the coordinator. And is the second speaker is here, Professor Prasanna?
Prasanna sir is there?
If Mr. Prasanna is not here, then we can continue asking.
So I don't think so, sir. Prasanna sir is having the other work.
So he's coming?
I don't think so, sir. So kindly check once.
I don't know where is the coordinator.
And with the methods of the large areas that is filled, how can we differentiate between larval ages of the pest? So the question that is how can we differentiate between the different larval ages of the pest and the presence of the other pests, and where the biological methods at the level of large areas, that is the field, are only in the laboratory. So we can very easily what I feel is, so differentiating the larval, that too in the early stage, we need to have the frequent field visits. You should have very close association with the different pests which are occurring on the crop. That is very much the fundamental, the information what you need to have. Then only we can identify this is of Spodoptera frugiparda, this is Spodoptera litura, or this is the Chylopatulus or Sesamia inferens. We need to have work with the insects, then only we will very easily we can identify. And with respect to the biological methods, yes, of course, these will work under the very well under suitable environmental conditions. As we all know, these biological control agents, they have their own limitations. When there is a favorable environmental conditions, automatically there is no doubt the natural enemies which helps in bringing down the pest population. So what about the using microbial control with baculoviruses, bacteria and other microbes? So baculoviruses only we got
just
very
wait,
few.
Please wait, Dr. Wael. Just wait. Anyway, there is a question from Dr. Wael. Hello?
Hello? Hello?
Yes, go ahead, Dr. Wael. Ask.
Hello?
Okay, go ahead.
Hello? الو تسمعني؟
ايوه
تسمعني؟
اسمعك
الو؟
اسمعك
الو؟
بس.
انا كنت عاوز اسال.
تفضل.
انا كنت عاوز اسال حضرتك استخدمت المبيد النيم، ما تاثير مبيد النيم على دودة الحشد والمود اوف اكشن اللي اثر فيه مبيد النيم على باستخدامه يعني على الدوده، يعني هل كان ليه نتائج طيبه، خاصه انه يعني مبيد مش منتشر كتير قوي يعني في اماكن مختلفه. الو.
So one question, may I answer to these questions?
الو.
Hello.
الو سامعني؟ الو. الو.
Yes, I will translate because he unmute me. So please, I translated Dr. Sharan. The question of Dr. Wael, he said, what's the efficacy of azadiractine or neem on fall armyworm? Is it efficient or not efficient?
So with respect to the azadiractine,
yes.
So we are having the two formulations in India. One is 1 EC, that is 10,000 ppm, and another one is the 50,000 ppm, that is a 5 EC. So we tried the 10,000 ppm, that is 1 EC at the rate of 2 ml per liter of water, and also the 5 EC, that is a 50,000 ppm at the rate of 0.5 ml per liter of water. So for the early instarts only, it gave good results, not for the later instarts.
That's right.
We can recommend this one as a first spray. When the infestation starts, when the crop is around 15 to 20 days old, if you recommend the azadirachtin as the first spray, when the larvae are very small, neonate, then it is effective, not for the later instars.
That's right. Can we mix it with a bacteria? Is it available, or I mean, it's possible, or
I don't know, Professor. I don't know the compatibility of these two. So we have not tried that one.
Mm-hmm. I don't know how long we stay. Where is the coordinator?
Yeah.
It seems to me you are staying instead of Prasanna.
Yeah, so I know Prasanna sir, but Prasanna sir today is having some other work.
Okay.
Prasanna sir is always helping us. He is having vast experience with this fall armyworm. Really,
yeah, but
today we are missing his presentation.
He is a plant breeder, actually, or not?
Yeah, he's a plant breeder, but he is much exposed to this pest. So he is working with the African group, Indian group. So he is also having a very wide experience with, though he is a plant breeder.
He announced in the last meeting there is 3 resistance tolerant, let me say, tolerant varieties.
Yes.
And you said about the for the participant, maybe the information about the baculovirus. Now they produce it in India. I mean, the English company, they produce it in India with the United Phosphorus, I believe, and for the sake of Africa only.
At this juncture, for the sake of Africa, they are releasing.
Yes, only.
Africa
I
only.
know. Is there any question? Can I unmute the guys? I don't know how. Ahmed Said, can you interfere with the coordinator, please? Dr. Hussam, can you call the coordinator? So there is one, Ahmed Abdul Wali. Go ahead, please. You are unmuted.
Okay, دكتور ابراهيم.
Go ahead.
معلش كان عندي مشكله في المايك.
يلا ولا يهمك. خلاص انا درت مكانك.
Thank you so much.
Thank you. Okay.
Okay. Any other questions? I think in the text box there is an English question here.
Yeah, in the text.
Yeah, in the chat box.
In chat box, I have so many questions. So those who are interested to know more about this fall armyworms, they can write an email to me. Already I have typed my email ID, and I can give the answers to the maximum, whatever I know. That one.
Okay, we still have plenty of time. If any of you guys want to ask. Yeah, okay, I think that's it. Thank you, Dr. Deshmach, for that presentation. I think you made it so clear. Yeah, thank you so much.
Thank you, Professor. Thank you, Dr. Ibrahim, sir, and all the participants who have given me an opportunity to share my little experience with the fall armyworm. Thank you once again.
Thank you so much.
Thank you.
Okay. We still have time for David, the next speaker. So I don't know. I'm going to double check if he is around.
Next speaker is Dr. David, I think so. David Montejana.
Yeah.
We also published one paper with him on the bioefficacy and also the toxicity of the insecticides.
Yeah, I think he's not around, so we will be waiting for him.
Hello, you can give me around 5 or 10 minutes because I thought that my talk was going to be at 8. So,
okay, we will be waiting. Okay.
Yeah. So what about 7:25 or 7:30?
7 like
Like a 10 minutes or 15 minutes.
10 minutes. Okay, we'll try to find other people to talk. So
Mr. Ahmed, now we have our next speaker, Dr. David, is with us now.
Yeah, but he still had time, need time to prepare himself. So he needs like 7 minutes.
Okay, he now has the floor. Okay.
Yeah. Okay, Dr. Deshmokh, if there any declaration you can say, or any other guys who want to ask about your talk, so.
I thank profusely the organizers and also the organization, because you have took the lot of effort in organizing this international webinar. Because whatever the resource persons, what I saw in the list, all they are of internationally renowned scientists. They are well exposed to this fall armyworm. So Dr. Robert Meager, he is having more than 25 years of experience with fall armyworm. Yesterday, who presented the fall armyworm scouting and other things. And also Dr. David Montezena. Now he is going to present the talk on the pesticides and the pesticide resistance. He is also having vast experience. You have selected a very good the resource persons, and also you have planned so meticulously, and it is of a very well organized the webinar. Once again, I thank all the organizers and also the hands behind this webinar who really struggled very hard in organizing this fantastic international webinar.
Yeah, you bet, Dr. Deshmokh. Yeah, thank you so much for that.
Thank you very much.
Okay, thank you so much. Yeah, we got lucky to have you today.
Yeah. So may I know what is the status of this fall armyworm in your country?
Yeah, excuse me, Dr. Deshmokh, did you ask about me?
So what is the status of this fall armyworm in your country?
In every country?
Yeah, in Egypt, what
in
is
our
the
country?
status?
Oh yeah, still under investigation. All of the research now under investigation. There is no final report for that. But I think, yeah, there were a lot of people here interested, and yeah, I think they do their best, yeah, to find any new strategies or any new approaches or novel stuff to deal with.
Yeah, it was also a very well organized, very big organization. So many scientists you have. So if you have any collaboration, certainly we can work together to mitigate this fall armyworm.
Oh yeah, of course. Yesterday, you know, Dr. Reed Harrison from Zambia. He asked all the people here to join with him and collaborate with him to do some research. Yeah, and I think everybody will be benefit from that workshop that way. So
yeah, certainly.
Yeah. We will be waiting like 2-3 minutes more.
I also thank the Shaban sir who initially contacted me. So regarding this webinar also.
You bet.
So anyone is contacting Dr. David?
Yeah, we contacted with him. He just asked, like, give him like 7 minutes to start his presentation. So Everybody waiting for him.
Yeah. Yeah, he joined.
Yeah. David, are you here? Hi, David, are you
Hey,
here?
pleased to see you.
Yeah. Thank you.
Good morning
so much.
here.
Yeah.
Hi, David. How are you?
Hey, Sharanu, how are you?
Fine.
Yeah. Well,
How about
folks.
you?
Excellent
Now,
presentation.
Nice to see you.
Yeah.
yeah. Okay, guys. Now let's move on to our next speaker, Dr. David Mota Sanchez, Assistant Professor at the Department of Entomology, Michigan State University, USA, and Dr. Sanchez research focuses on the evolution of arthropods resistant to pesticides, insecticide toxicology, and metabolism of pesticide in insects. So David, are you ready?
Yes. Let me
Okay.
screen. Good morning, everybody.
Okay, go for it.
Let me see. Okay, can everybody see the?
Yeah.
Just let me get to the first presentation.
Okay.
Okay, can everybody see the?
Yeah.
The presentation?
We can see it. Go ahead.
Okay, excellent.
Yeah.
Thank you for the invitation to the organizers, the Plant Protection Research Institute, and I really impressed. I wasn't in the first talks, but I really impressed after the half of the morning. I attended the talks starting from Dr. Miguel from ARS. So, and today I just see the talk from Charanu, and it was wonderful, and previous talk also. So I want to talk about pesticide management and resistance, and I want to even that I'm working in the United States. I'm originally from Mexico, and Mexico is the center of origin of core, and of course there is association of core. Is very important part of the culture. So Mexico is, there are many 48 different languages, and there are different nations, Native American nations, and there are different types of core, like you can see here, different colors. It's very deep, this plant and the culture and the food. But fall armyworm is an important piece of the crop. I see fields totally devastated by this insect. And if you see the records of the natural enemies, perhaps Mexico is one of the countries that reported more species or natural enemies attacking fall armyworm. But as mentioned by Dr. Deshmukh, even that you had all of this amount of natural enemies, still the people spray pesticide to control fall armyworm. Perhaps the situation would be completely difficult without these natural controls performed by natural enemies. Here is the distribution of the fall armyworm in the American continents. It's from the US, mainly the US, as our the speaker from the ARS, Dr. Rapp, talk. Basically, the migration of the fall armyworm is from the south. In the spring, the winds blow from the south to the north, and then there is a migration of moths, not only from the Florida or Texas, but they come from the Gulf of Mexico and from the central part of Mexico. So there is a contribution of the movement of these species to the north. And also, it is not a story, but there should be some migration also from the Central America to the central part of Mexico. So it's a pest. Of course, there are local resident populations, but also there is a lot of movement of this pest. And I suspect that this is the case also in Asia and many countries. This is going to be like this type of movement based on the movement of the winds. Dr. Deshmukh brilliantly presented the life cycle and many things about the fall armyworm, but so I'm not going to go in this also, since he really made a great contribution to this part. There are many compounds that control the fall armyworm. There are compounds that targets the growth and development targets, nerve and muscle targets, respiration targets, mid-gut targets, and other compounds known to control fall armyworm. And here are some of the pictures. I forgot to bring some table from my office, and at the time I realized it was too late with all the compounds used against this insect, but I promised to send it in the week to the organizers. So these are some pictures of the effects of fall armyworm. For example, when you apply, we do studies in the laboratory, and we apply 24 hours and 72 hours of different days to evaluate. And here are for example, the compounds acetylcholinesterase inhibitors, metomyl thiodecarbchlorpyrifos, and you see the size in comparison with the control at 24 hours. And then you can see here the effect at 72 hours. And then we had so many different pictures of these effects. Pyrethroids, this is the effect in comparison with the control. Of course, here you cannot see the movement or the behavior after being treated. But this is the effects in a susceptible population. And here is the effect on another insect growth regulator, triflumaron. And 72 hours, you see like the insect cannot release the skin. There is no way to mold for this larva. And even that this larva is big, is going to die because of the effect of the insect growth regulator. So there are many compounds, old compounds, new compounds, novel compounds that are in process to control this pest. As always, we think that is brilliant the future. But I think that I'm going to mention my experience with two systems, one in Mexico and other in Puerto Rico and the US. Before that, Dr. Deshmukh was mentioning that, of course, the natural enemies is really important, but sometimes there is no time and you need to express. And this is a resource that he performed in India. And there are examples all over the world. You can find examples that there are no real effect on the damage and the yield. But the reality is that in many times when there is a high geographical area that there is an infestation, there is some conditions. You can see here, for example, that after two pesticide treatments, here is the control, and these are different compounds: chlorantraniliprole, emamectin benzoate, spinoteran, fluindamide, pyrethroid lambda, cialotrin, indoxacar, and novaluron. All of these two sprays of compound increase to 2 to 3, more than 3 tons in difference in yield. Of course, this is variable according to the area. If the infestation is very low, is no just one apply spray or no spray, you can have a control of the pest. But all of this depends on the geographical areas. For example, in Puerto Rico and Mexico, I've seen places that are completely devastated. So the farmers must spray, otherwise there is almost to 75 to 100% damage. And I want to mention, I think that Ralph mentioned that in most of the US, most of the control of the fall armyworm is by genetic engineered crops, Bt toxins, and there are several Bt toxins. But in some areas, like tropical areas, for example, I'm going to mention the example of Puerto Rico. Most of the control performed in these areas. In South America, of course, they use transgenic crops. But Central America and Mexico, most of the control of the fall armyworm is with pesticides because there are no Bt crops. So in the case, for example, of Mexico, the most use of pesticides used against any pest is against fall armyworm, because the importance of the core. So since there are no BT crops, farmers need to spray, and it can be from 1, 2 to 6, or sometimes 8 sprays. All depends on the season, weather conditions. It was mentioning that the rain of course drown the larvae, drop the slush, the neonates or small larvae from the foliage, and drown some of the larvae. But I see more in the case of Mexico, more dramatic effects of when it's the dry season, or corn under irrigated conditions is the most heavily infested by fall armyworm. So one of the things that is really important to control this pest is to control early starts. However, this is something that is necessary. You start spraying immediately against first and second. Still you need to spray more. No, you wait a little, you can spray delay a few days, but not too much, because one of the things that when the larvae go into the wall of the plant, it is hard to control. Basically, you need to go plant by plant, or using the nozzle is very important. The application is very important to control this pest. The calibration is very important. 200 to 300 liters of water. 300 is better than 200 to control the pest. Most of the thing people say, okay, if you put more water, you are diluting the compound. It's right. But the thing that happened, that is better to have a very good coverage of the wall of the plant to control fall armyworm. I see some cases of drone spraying pesticides, and it looks like it's really a fancy technology, but the ability, for example, in the case of we an AXAT sprayer, if somebody can reach 90% of control in Mexico, in the central part of Mexico, spraying by this simple equipment. In contrast, if you use the other equipment or the tractor, you can reach about 80% control. It still is faster, no? But the thing that happened with this pest is the behavior, and the larvae that are going to the wall of the plant is the problem. In your left, you see this larvae. This plant, this is an attack on early stages, and this is a problem. In some cases, the infestation is very high. The crop can be affected. Many plants can be destroyed. Another thing that happens is that sometimes the larvae sterol for instar. So one of the things that happen in some behavior observed in Mexico is that they cut the base of the plant and move to the next plant, and move to the next plant. So it's not uncommon to find this situation of this attack of the fall armyworm. One of the things that happens, I'm going to introduce a little bit one concept or resistance. So resistance is when you spray pesticides against a population in the field, and here there are only one red individual. And the thing that happens, of course, can be 1,000, 10,000, 100,000, 1,000,000, 110,000,000. You apply pesticides and you control, and then some susceptibles escape because didn't reached by the compound, the resistance survive. After many rounds of application, you have these problems. You have a substitution. And why I mention this, because it seems like never is going to happen. Perhaps some of the fall armyworm that arrive to Egypt, they are susceptible. Of course, it is very likely that they carry some alleles for resistance. So resistance can happen. I'm going to introduce some few comments, and then I'm going to go to the point of showing some cases of resistance. In 1914, the first case of resistance was reported in the San Jose scale. And then somebody observed Melander that the compounds of sulfur compounds didn't kill the San Jose scale. There were survivors. And then at that time, the people didn't thought that the insects can become resistant to sprays. But after many observations, they were convinced that resistance exists. And of course, resistance exists, is microevolution. And one of the things that he said, and it's the principle for everything, he said, Melander, in 1940, we might have to introduce a weak strain of the San Jose scale to cross with the immunes and thus return to the normal susceptible population. This is, in essence, this is the principle of using the refuge. In BT crops, there is an area that is not, there is no a BT crops, the refuge only to produce susceptible individuals that may be resistant and dilute the resistance. And this process can be applied to IP and IRM to any situation to preserve the susceptibility to the pest. This is a graph of the pest cases of resistance all over the world since 1914. 612 species, about 17,000 cases to 348 compounds. So this is data from our pesticide resistant database. I am the co-director of the pesticide resistant database. And we house this database at Michigan State University. One important concept in resistance is the use of a susceptible population. And then there is another concept that is called the resistance ratio, que basically is using different doses is calculated. It's like using probe analysis is estimated the LD50 of the field population. And if we use a susceptible population, we can compare how many times the resistant population has developed resistance in comparison with the susceptible. So this is the resistance ratio, and this is the log dose mortality, the mortality and the log of the doses. And this is important concept in toxicology and resistance. And one of the things that is really important is that there are many papers of resistance, and there are many people that select resistance in the lab. But this resistance is to example of prediction of what can happen in the future. And this is a good situation. It's not exactly the field situation, but it's really good. But one of the things that happens, for many years, there were a little bit of discussion between the industry and academic, because the industry say, well, you are reporting that is field evolved resistance, but still we don't see problems in the field. And then with Bruce Tabashny, Yves Carrier, and our team at Michigan State University, we coined the term practical resistance. You can have resistance in the field, but this resistance is detected in the lab, and still you can, at the field rate, you can control the pest. So this is field evolved resistance, and it's necessary to be careful about the potential development of resistance, but it's still not in practical resistance. Practical resistance is when the compound didn't work in the field. And here is some website of our database. You can access our pesticide resistant database. If you need questions, you can find me here also. You can Google my name, and then you can find me in the web. So, so the situation that happens is like, in many cases, you will see all these compounds controlled very well, and there is no problem. But the situation is that fall armyworm has developed resistance to DDT, cyclodienes, carbamaze, OPs, pyrethroids, OPs. Against all of this, this is the historical records of resistance during the time. BTs, organophosphates, pyrethroids, carbamaze, nicotine, well, this is pyrethroids, inhibitors of the synthesis of chitin, rhinodine receptors, nicotine acetylcholine receptors, allosteric modulators like a spinoteran. Our system that we are working is in Puerto Rico, and also the pest has developed resistance to Cry1F in Puerto Rico. And one of the factors that was favorable for developing resistance was geographic isolation, reduced refuge, drought, and migration. And Nick Storre found resistant, and Carlos Blanco also found resistant to Cry1F in Puerto Rico. With my student, Rebecca Gutierrez Moreno, when she came to MSU, she told me that she wanted to work with an insect that benefits Mexico, because we are very up north in the US and fall armyworm arrived, but we had the BTs. So basically we don't have problems with the pests because we are very in the Midwest and we have the BT crops. But she wanted to do her PhD dissertation with a pest that benefits Mexico because she's from Mexico. And then we start collecting populations, usually in those two systems, Puerto Rico, you don't know, Puerto Rico is one of the most strategic places in plant breeding for corn. There are about 80% of the seeds used in the world pass to these nurseries in Puerto Rico. It's not corn for production, but it's for seed production. So, and the system is that there are used up to 29 sprays per year, no? So there are many more actions, and in Mexico there are is different. The area is bigger, and it's one of the countries that consume more compound, more corn. But there are really two different systems. In Mexico we have similar conditions than Puerto Rico, but there are different systems. So we had the corn production since the best technology in the north, like Sinaloa, Sonora, Jalisco, to Oaxaca, that still there is a very ancient way of producing corn. And then in Puerto Rico, corn, you had a lot of technology. So we decided to given these two characteristics, to study the resistant developments in Puerto Rico. And here is one of the examples. I'm here in this part of the Great Lakes area. This is located in Michigan State University. And here is the work that I had the research from Puerto Rico. And here you can see one of the treatment. This is a pyrethroid treatment in Puerto Rico. Basically, there are no difference between the control and pyrethroids in the field. Pyrethroids is really innocuous to the fall armyworm. And then in other places also there is a reduced control. Even in Africa and Asia, you can find reduced control of pyrethroids. So there is a long time of selection for pyrethroids. And before that, DDT, and there are sometimes a little bit of cross resistance, or mechanism of resistance that this pest evolved to pyrethroids. We do topical bioassays. We use second instar larvae, and this is a classical micro applicators who apply 1 microliter of pesticides. We do tests also in BTs, and we use this system. We use trace. Now we switch from the system, the topical applications, to this overlay dye assays that to me is more easy. It's a standard. We can compare our results with the results from Brazil. So, so it is more standard technique. And here are the situation with resistance. This is dye mice. This is the resistance ratios from accepted population from provided by Bayer to us. And then this is the publication from Gutierrez Moreno. And this is the populations from Mexico. That doesn't mean that all the populations from Mexico are susceptible. But in the places that we collect is a kind of pristine area, Oaxaca, the resistance ratios are very low. Jalisco, Coahuila, and Sinaloa, there we found a little bit of resistance, but very low resistance. But you can see here the levels of resistance from Puerto Rico. Fluvendiamide is extremely high levels of resistance, followed by chloranantramiprol. So it's very high levels of resistance, or resistant is resistant. And then if we check other compounds, you can see here Spinoteran, or comparison of all other populations. And you can see here the population from Puerto Rico. This is a compound, is resistant to Spinoteran, but also is resistant to spinosad. The thing that happened is have passed the similar situation that happened with Cry1F. There were overuse of spinosad, and that led to these problems. Resistant to chlorpyrifos, also lorsban. There is resistant to lorsban, and then in Mexico there are a little bioresistance. Metomil, we tested a lot of metomil in Mexico in different bioassays, and I never thought I was going to foliar ore would develop resistance to metomil. And here you can see the extremely high levels of resistance to metomil is really high. And then for permethrin, of course, permethrin is a pyrethroid that foliar ore has this tendency to develop high levels of resistance to pyrethroids. One concept that we introduce in this is always using the toxicology and pharmacology is the potential ratio. So you test many different compounds and calculate LD50, and then you divide which compound is more potent. So abamectin is the less potent compound, you need more compound. But as you can see here, emamectin benzoate is the most potent compound. From this compound testes follow chloranthraquinol, spinoteran, insect growth regulators. But this doesn't mean that the other compounds doesn't work. Means that the amount of compound that you need to get a 50% of the virus, or the foliar ores, is really very low amounts. And usually this is reflecting the efficacy of the compound in the field. This is the susceptible population. And this is our resistant population. So the only compound that was similar than the susceptible was emamectin benzoate. And I'm going to show you in some few slides what is the effect that happens that you can see the resistance. And then there is a reduction in the potency to the other compounds because they are develop a resistance. So this is one of the most resistant pesticide, strain of population to pesticides in the world. But it's a model. I mean, this is like it's not exactly the situation that is happening all over the world. But in my trips to Asia, I think that I see similar conditions in for example, I'm going to show in one slide more. So there are similar conditions that can lead to these resistant developments. And in practical terms, not in the case for a farming in practical aspects, but in evaluation, we call the plants since the base, from the basement, and we explore, of course, we explore and count all the larvae, and we classify by small larvae, first and second instar, medium larvae, or large larvae. And you can see here the efficacy of emamectin in Puerto Rico is very high. This is, I think that the red is large larvae and the green is medium larvae. And emamectin benzoate, very potent compound, followed by chloranthraquinol, but you see a lot of survivals. And then we see indoxacar, fenvalerate, and the control. So it's fenvalerate, basically it is the same than the control. Okay, so these are different doses in two populations. One population that is the susceptible in our bioassays in overlaid diacetic. Basically, we have these cells and we spray 30 microliters of pesticides over the dye, let the insecticide solution to dry, and then we evaluate the mortality. And then this is just for the visual example. We have a resistant strain and a susceptible strain. And you can see here on your left the control. And different concentration, and you can see here alive larvae for methoxyphonazide at 1 ppm alive. But when these treatments were treated with 3.16, you start seeing this affected larvae, and the resistant strain is fine. And then when you reach 10 ppm in this treatment, the larvae is dead. But in the case of the resistant strain, you see survivals, and you see survivals at higher doses, in this case 100 ppm, a lot of survivals. So this is interesting because these compounds didn't work in terms of the practical resistance. Basically, they are resistant in the field. These compounds, it does so little. I mean, it's not like it's going to be 100% failure, but the percentage of control is going to be very low. And then for strain validate, the similar situation, these are susceptible and this is the resistance. And here is more, the situation with the susceptible is like you need more compound to kill, and then at 10 ppm you start seeing affected, but then the situation is like there are survivals in the resistant strain. So this is another distinction that you can see, and this is reflected in practical resistance. Is as I mentioned before, in the control in the field, in field plots, basically is the same. You cannot distinguish only looking at your map or the way that you say the design. You can distinguish which one is the control and which one is the streaming a pyrethroids against fall armyworm. And then we chloranantralniloprol also for our resistant and susceptible strains. We see many, the compound is very effective. I mean, in the field against different populations is very effective. But in a resistant strains, there are so many survivors. You need 100 ppm to start seeing the effects on the larvae. Sometimes the thing that you can see when there is a transition to resistance, you start seeing more feeding in the, not in the work, but in the foliage outside of the work. You see more feeding effects. So this is diamice. Emamectin benzoate, but here see the effects. We didn't include more doses below because we thought that the emamectin will survive. But you see that basically there is no difference between the susceptible and the resistant strain. Emamectin is very, very effective. But as I am talking, perhaps in 10 or 20 years, if somebody recall this or remember this talk, they are going to think that emamectin can be, now is a compound that is very effective, but in the future perhaps can be like a pyrethroids, no? If there is no appropriate or sustainable or adoption YP and IRM plan. So this is a compound that is very effective, as I mentioned, but that doesn't mean that it's not going to happen. We have a sense of confidence. Oh, this compound is really good, nothing is going to happen, but it happens. And there are many cases to BTs, to any tool used against a pest. Eventually there is a delayed resistance, but there is no an unlimited use or deployment of pesticides because they are expensive compounds. So it's important to use all the tools, as Dr. Dyson mentioned. One other thing that happens with the mice, you see that so many times the fall armyworm attacks the small plants, and then there is incorporation of diamide coated the compounds with another pesticide to control the pest. And this is really good. But one other thing that happens is like it's very important to be careful. It's a nice tool, but it's important to be careful. My PhD students Omar Pozos cross the resistant strains with the susceptible, and the resistant is codominant. So it means that when the compound, if there are a resistant population or there are some heterozygous populations in the field, they are going to start, and as the pesticide residues decay, they are going to be a rapid development of resistance. And this resistance happens very quickly in Spodoptera exigua and Diamond bat moth. So it is important to use this tool. It's very good, but it's important to use appropriate tools. Here is one of our trip to Myanmar in 2018 with Dr. Karim Maredia. It's an effort supported by the US. And then we visit fields, and I see similar conditions than Puerto Rico, hot weather. Actually, the access to pesticides is no problem. farmers can use emamectin, spinoteran, chloranantraniliprol, but you see a very high pest infestation. Many egg masses, 8 egg masses per 5 egg masses per plant, 8 larvae per plant, and you can see here is almost total destruction of the crop. So, and the farmers spray, but one of the issues that we see is the quality of the product perhaps is not the best, even that there are really good molecules. And also the water, the amount of water that they use and direct application of the water is critical. If you don't do this, the larvae is going to survive and hide in the water of the plant and survive and cause, cause a lot of problems because they destroy the growing tip of the core, and then the plant doesn't develop. And here is one of the papers. This fall armyworms, they have a close relationship to the origin to Africa and India. This Dr. Rotna Ghoshi that has doing great work in tracking this in Galapagos Islands, Mexico, many different places in the world. This is a slide borrowed from my friend Dr. Celso Moto from Brazil. And then they found resistance, no high frequency to organochloride, pyretrols, and basoyl ureas, intermediate resistant to spinosas and carbamates, and low resistant to indoxacartide, mice, and some BTs, no formulated compounds. But this situation changed a lot. This is a dynamic situation. It's not like as we speak, there are changes, no? And more in Brazil, there is a high commercial production, and they have cotton, they had corn, and they have soybean, no? And there are some movement of the peso. This is more selection, and there is a person from Brazil that is going to talk about this this situation, and they are the experts in this part. We run bioassays also in BTs, and we have high levels of resistance. Since 2010, that was detected, we collected populations, and we found very high levels of resistance. This is the resistant strain from Puerto Rico, and these are susceptible strain. Even with the high doses, we have found less than 5% mortality. So it really fixing the population. The industry don't use any more Cry1F or hybrids we BT toxins. That, of course, they are using for the procedure, but most of the control is with synthetic insecticides. Now, well, I would like to mention quickly that one of the situation is now, and also it's easy, it should be here, is like from this distribution, when we started working in Michigan, before working in Michigan, I was working in Mexico. And let me tell you that in Mexico, I started working since long time ago, since I was undergrad student in Chapingo is the name of the university. We visit CIMIT, and they have many colonies of many lepidopterans, and we invest in the fuel core plants to do trials, no, or pesticides mainly. Or we went to the other areas in Mexico to do trials, and then we tested different compounds. But I never thought it was going to be this situation now all over the world, the fall armyworm, and it's going to be an interesting problem in the next 5 to 10 years. My prediction is this pest, I think, that is in the top 20 from 20 to 30 most important species that develop resistance to pesticide. But my prediction is that in the next 10 years, it's going to be in the top 5 species to develop resistance in the world, because this is distribution and access to pesticides in different countries. So what to do? Charanu, Dr. Deshmukh presented here the situation with IPM, you know? So it's important. I don't know, you like to, I know that there are many excellent chess players in Egypt, and then this is one game I was tired, and sometimes I play chess online, and I trying to find an example. No, I don't know. You see this famous series, the Netflix, the Queen Gambit, But the situation is that the queen is the most important place in the most powerful piece in the board. But if somebody careless expose the queen, is attacked and harassed. And in this case, I deploy the bishop here and he's attacking the queen. So he cannot move the pawn because I'm going to, if he's going to, I can give you, he will be in check. So he's going to lose material and eventually he's going to lose. But in this situation of pest management, the insect has millions of years dealing with secondary compounds from the plants, and there is a coevolution. And for us, is the use of synthetic pesticides in 1940s to now is a very short time, is a millisecond in the evolutionary scale. So it is important to have these games, and there are many ways that the people has different styles to manage to play the game. But in essence, you have the rules of the game. And then, as Dr. Deshmukh mentioned, there are parasitoids, there are other things that can be incorporated. Even a pawn can be converted in the queen and can make difference at the end of the game or in a positional things. So this is the way that I see the insecticide resistance management and pest management. It's not like I want, it's very serious. But my example is using the chess to say that it is important to use all possible tools and tactics and deploy very well your positions in the chessboard. And one of the things that happens with the industry, where we organized a workshop in Puerto Rico, and all the sea industry was there, and it was really great because the main companies were there, and we collect the population, we do laboratory essays, and we do field plots. It was a fantastic workshop, and using the real situation, assessing the things in the field is like you have this sense of satisfaction that you are in the same page, no? That everything that you see, other people are seeing, and then you have more uniform criteria. And then again, there are many situations, no? You need to, in Mexico, use a lot this bouquet with the pheromone, with water, to capture the moths. As Rap mentioned, it's like a method to detecting the population. Some people mentioned that, oh, there is this extraordinary pheromone that is going to solve the situation. But the thing that happened that is like a mobile pest, it's moving from different areas, no? And there are situations that we don't know. Maybe there is a way or moths migrating, and some of the moths can be already mating, and some the females can still target the crop. And then IPM is very important. If you use pesticide like a last resort, you need to be careful and wise in the way, like a proper calibration, protect the equipment, many things that happens, and to do, you need to use in the best possible way. Oh, I forgot to mention that Dr. Dyson mentioned neem. I tried neem and BTs in Oaxaca, in Mexico. I think it was 20 years ago, more than 20 years ago. And it wasn't like a synthetic pesticide. The effects still in the case of neem or BT, you see a small larvae, but when you compare the damage, the appearance of the crop was similar than other chemical pesticides. Of course, all this depends on the infestation. As a directing is not very effective against third-instar larvae. First and second is very good, but third-instar larvae is not bad. But then again, we are talking about IPM, IRM. There are some deleterious effects in the population, no? And it's still causing some fitness problems in the survival of the insects. And I have a long list of persons that have been supporting our work. The seed industry in Puerto Rico, Dr. Henry Terán Santofimio is a really good friend of mine, Dr. Diego Vicleri from the University of Puerto Rico. My PhD student, Celso Moto, my friend from Brazil, Dr. Ralph Nawen, of course, my friend also Deshmu, that he's doing a fantastic work. Other collaborators really good. Rodnagos, Carlos Blanco, Karim Maredia, the USDA FES, and also I dedicate this work to or this presentation to Moya and Sila. I didn't have here the presentation, but Moya was a USDA fellow that was in my lab, and she passed away last year, but she was a fantastic person, scientist from Zambia that started the working in Ning, and we are focusing also in botanical compounds to manage fall armyworm, and Dr. Mukanga Muyeshi and Mus Mwale from Sari. With that, I would like to entertain any questions you have. So thank you so much for the invitation. Hello? I don't hear anybody.
السلام عليكم. الصوت مسموع؟
Hello.
السلام عليكم.
I think that we lost our coordinator.
لدي سؤال إذا سمحت لي سيدي. أريد أن أسأل عن استخدام منظمات النمو الحشرية أو مانعات الانسلاخ GR كالتفلوبنزولون والدفلوبنزولون. هل يوجد تجارب ميدانية عن عمل هذه المبيدات؟ وإذا كان هناك بعض هذه التجارب أرجو أن توضحها لنا، لما لهذه المبيدات من أهمية كبيرة جدا جدا في التقليل من استخدام المبيدات الكيميائية الكانسة أو العامة. فمن المعروف أن منظمات النمو أولا تبقى فترة زمنية طويلة في الطبيعة وتؤثر على الآفة خلال حوالي من 20 إلى 40 يوما، وبذلك فهي توفر علينا استخدام المبيدات الكيميائية ذات التأثير السلبي على البيئة وعلى المحصول، كما توفر علينا موضوع المقاومة الحشرية للمبيدات. وشكرا لكم.
Hey, David, did you get the
Yes.
question? Yeah, okay.
No, I didn't hear I hear in another language, but I didn't hear the question. If somebody can translate for me, I can also, I'm going to stop the share, and I'm going
to. Yeah.
Or you can write the questions. I can see in the chat the question.
Okay.
Hear the question. Mm-hmm.
لو تعيد السؤال تاني يا مستر، لو تعيد السؤال تاني. Yeah, okay. David, I'm the coordinator. Thank you so much. Yeah, thank you so much for your lecture, and just we will be waiting for any question will be coming. So I think the people will give us the question in Arabic, and we need to translate it. So just give us a second until we fix this problem.
Okay, okay. Thank you.
Okay. Any other question, guys?
أيوة ممكن.
Okay, go for it, Dr. Farid.
أيوة. My name is Farid Harras, PhD, Emeritus Chief Researcher at Plant Protection Research Institute, ARC, Egypt. Identifying resistance-related genes is helpful for the monitoring and prevention of fall armyworm outbreaks. But I am interested in the immune gene. I am interested in the immune gene of the insect. My question is, can we identify the immune gene of the fall armyworm? And later, can we introduce the double-stranded RNA molecules that match the immune gene sequences into the insect to silence the immune gene and increase the toxicity of BT toxins? Since BT toxins are pore-forming toxins. Thank you.
I think that if I understood well, you want to identify the gene for resistance?
Yes, yes.
Yeah, I think that is, yeah, I think that with the sequence is possible. I mean, it takes time, but it's possible to do this, especially in the case of fall armyworm, there are broad detoxification enzymes like a P450, like a esterases, like a glutathione transferases. So there is some kind of physiological approach, like I use in PBO to suppress P450 enzymes. And then if there is drop in resistance, there is a suspect of this mechanism or death in mix of, for example, esterases, in mix of organophosphate. And there are other synergies. One of the things that is important, I think, is like now is the time that you have your baseline susceptibility to different pesticides, because as the time passes, there is going to be selection, and you are not going to know how. I mean, now is the time that you can rear the column in the lab and then use different approaches. Like you can. My suggestion is to compare with a system, you know, like the system that we have or the system that people in Brazil has or in India or in China, to compare your data, because you don't have a resistant population. And it's very difficult to move this style of population, no, from one country to another. And then, but still you can compare your data with data from other places of the world. But I think that is feasible, and it's interesting to see, to do different approaches, the use of synergies, sequence, doing transcriptome or sequence of different parts of the genome or the species, and then do a lot of work. No? So it's many different situations, but it's important also the practical aspects or different deployments on different factors of mortality to delay resistance. No? And I mentioned when it is necessary. It's not, as you may see, it's different talks. Not always you are going to need to spray pesticides, and this is the last resource.
That is the RNA interference strategy, and we are looking for to apply this strategy. Since, you know, BT toxins are pore-forming toxins, pore-forming toxins, and the mid-gut bacteria is responsible for the toxicity. It exits to the hemolymph and make septicemia for the insect, and this is the cause of the death of BT toxins. BT toxins, they make only pores, and the mid-gut bacteria exit to the hemolymph, resulting in septicemia for the insect, and this is the cause of the death. So we try to silence the gene of the immune of the insect, so the toxins can increase its toxicity by this way.
Oh, this is fantastic. This is fantastic to suppress some type of this mechanism, and then the compound can be more effective. I didn't know much about the BT resistance because I thought that you wanted to see other things, but of course the BT, you know, the effects on the mid-gut, the effects. There are many mechanisms and many different types of BT, slightly different from others. But I think that is really important. Usually BTs are not very effective. I mean, it's not like a pesticide, but you can achieve very good percentage of control. And if you do this approach, can be the increased factors of mortality can be high.
That's right.
I was talking with a friend of mine in Mexico, and because sometimes the larvae, in some cases, reach the cob, and the farmers spray in the R1 or R2. But it's kind of messy to apply against when the fall armyworm is going to R1 or R2, no? Because you need to be in the field, or you don't have the equipment. It's really complicated to have this equipment for this type of sprays. But he told me that BT is used R1 or R2 in central part of Mexico.
Thank you.
Yeah. Thank you,
So
David.
much.
Yeah. Any
Excellent
other questions, guys? Yeah. Any other questions? I can see a lot of raising hands here, but I think.
I have a question, please.
Yeah, go for it, Doctor.
So thank you, Dr. Sanchez, for this very informative presentation. And my question is related. Should we keep monitoring insecticide resistance during the season, or so should we frequently collecting the pesticide resistant information, or it should be like maybe at the beginning of each season? And do you think we should recommend more than one pesticide to just avoiding the built-in of pesticide resistant? Thank you.
I think that is great questions. I think that all depends on the intensity of the treatment. No, I have never been in Egypt, and I don't know how is the cropping systems. For example, in Mexico, we know that if we go to Oaxaca, like there are pristine areas that the people rarely use pesticides, and there are higher elevations. The populations are going to be susceptible. We collect the population from that place because it's like a kind of reference or comparison. But in other areas that is a high yield production, and then they need to maximize the production, the farmers are obligated to use pesticides. In that case, it's more important to do more monitoring, no, at the beginning of the season, annual or 2 years. But all of this depends on the situation. And regarding the questions to miss pesticides, I mean, this is the principle used in tuberculosis, to avoid resistance, to use different antibiotics to avoid that one bacteria can develop, one bacteria can have a gene for resistance. And this is the basic principle that is applied to pesticides. And in BT works very well to use the different pyramids, different BT genes to avoid resistance, and that delays resistance instead of using a single BT toxin. In the case of pesticides in the field, I think that is not the best strategy to mix the compounds, because with the BT plants, usually or in general the plant express the BT through the season, with a little variation, but through the season. In the case of a pesticide application, there is a decay of the residue of pesticides, and then you can have a heterozygous individual that can develop resistance to both compounds. Can be a delay, but can be that. So my general recommendation is to use one pesticide and then rotate to other pesticides.
Yep. Okay. Yeah. Next question, Dr. Mtwali. Dr. Mtwali. Dr. Mtwali. I can see Dr. Ibrahim. Dr. Ibrahim Al-Jabouri.
Could you unmute him, please?
Yeah, I don't have that technician, so.
Thank you very much.
Yeah, here we go.
It's really interesting, very interesting. I mean,
yep, We got him.
First, I would translate the question of the first one who asked you about the insect growth regulator. Mr. Shadi. Mr. Shadi asked about the insect growth regulator. Are they still effective in, I mean, there, or we have, you know, we have in the area diflubenzuron and tiflobenzuron and whatever. Are they still effective? This is the first question of Mr. Shadi. Okay.
Well, there are different insect growth regulators, no? Inhibitors of the keating system like benzoyl phenylureas. Novaluron is still effective, but I think that I haven't looked into that. I haven't looked at triflomuron is not very effective. So mectopsenophaline is not very effective. So there is still novaluron. It seems like it is no use, but we check in the lab and it's good compound. But it's kind of multiple resistance to many compounds. I mean, like the colony that we have has developed resistance to.
What's about leufinuron? What's about leufinuron?
Leufinuron.
It's still effective in the area.
We have a lot of data, and I don't remember exactly leufinuron, but I can promise to write. You can get my email. I can write that part because we tested different compounds. I didn't want to bore you with all the compounds we tested. We have leufinuron, but I don't remember exactly how high is the problem with leufinuron.
So I come to my question now. Okay, this is my guy, my friend. Okay. I mean, you know, pyrethroids being used extensively in Africa, cypermethrin, alpha cypermethrin, and based on your data on S-fenvalerate, that means the fall armworm is highly resistant to all pyrethroid in general, as you mentioned in your I mean, presentation. So did you test or do you have feedback from Africa? How many folds is the resistance there against?
I haven't seen a lot of data from Africa. I review many papers from Africa, but I don't remember seeing one paper monitoring resistance in Africa. I suspect that my impression is like they can get some degree of control. But usually pyrethroids are not very effective everywhere. It's not very effective in the US. It's not effective in Puerto Rico. It's not effective in Mexico. The controls are very poor with pyrethroids. And I suspect that is going to be the case in Africa. I don't know how it's in Asia, but I think that it's not very effective compound. And the another situation that happened that is worse, I mean, I don't have anything about pyrethroid. I think that this is a wonderful.
So let me finalize.
I'm going to mention only this: the pyrethroids. The thing that happens is that kill natural enemies at the beginning. You don't want to kill many natural enemies at the beginning.
Okay. Yeah. I mean, sorry, Ahmed. ممكن last comment صغير.
Keep going. Okay.
Diamide, and chloronitripyrrole. I mean, as I know, fluvendamide. It's in the area, at least in our area or somewhere else, the company has withdrawn the fluvendamide because some resistance appear. Do you agree with me or no? I'm right.
I fully agree with you. Fluvendamide retired from Puerto Rico, from Mexico, and just there are the second issues: chlorananthraquinol, the other three related compounds. They are still more. There is a little biocross resistance, but not as much as chlorananthranilipropyl. So the other compounds are more potent.
Thank you very much.
Thank you so much.
Okay, another question. If any of you guys want to type, please. If you can find a way to talk, just try to type your question here in the box, and we'll try to find a way to connect with the lecturer, Dr. David. I think you did a good job. We'll still be waiting for any other questions. I think we have Dr. Ahmed Al-Morsi. We have a lot of people, but we'll try to unmute him.
دكتور أحمد، يس عندك هواي رافعين إيدهم.
Thank you. I'm really impressed for all of you. I the opportunity of going to Egypt. It's a wonderful country.
Yeah, we hope so.
I like the football team from Egypt also.
Yeah, thank you so much. We like all the Latino American football players.
Oh, thank you.
So if we have a look to the chat box, I think we got something.
Okay, yeah, I see some.
Yeah.
Okay, I see some questions here. Say the chloranantrap-niliprole. Well, Charano was making the point that are self-insecticides and that are coming in the future, no other related compounds to chloranantrap-niliprole. And then there is other question, can the alternance between the family of pesticide increase the control? Yeah, I think that is better to do this as the pesticide rotation, no? As I mentioned, there is going to be in the future more seed treatments with DMI. But then if the seed that is planting core is treated with the amide and you apply the amides against after the residual decay, I don't think that is very good. You should use other in either.
Hello.
Yep. I think we got that.
Assalamu alaikum.
Alaikum salam. Okay. Doctora Malika. Hello, Doctora Malika.
Yes.
Okay.
I have a question.
Sí.
Okay, go for it.
Are these pesticides which used to control this pest safe to environment and predators, which
You mute yourself. I think that you didn't finish the sentence.
Yeah, Doctora Malika. Doctora Malika.
I heard the first part only.
Okay, David, you can keep going with the question.
Okay, the questions. Okay.
Yeah.
Okay.
What go through them one by one.
Control like baculovirus, bacteria, nematodes, and fungi. I want European as they are safe to environment. Yes, I fully agree. We are not here to promote pesticides. We are like a working institution, and so we are using an integrated. And I think that is good. It's good to use all the potential tools. Is it possible to add diesel to irrigation water to eliminate? I didn't understand that, to eliminate pupa, perhaps. I don't know. I don't think to add
predators for predators.
For this, محمود عادل. محمود عادل.
محمود عبد الراضي.
محمود عبد الراضي.
السلام عليكم. بعض المزارعين في صعيد مصر بيضيفوا سولار على مية الري، وكان فعلا ليه نتائج كويسة. هل الموضوع ده توثق ولا مش موثق، ولا هو ايه يعني بالنسبة للأبحاث حاليا؟ إضافة السولار في مية الري لقتل العذارة الموجودة في الأرض.
طبعا هتموت.
Are there other pesticides of plant origin other than the neem plant? Yes, well, there are in Africa, no? And that was one of my projects, my Borlo fellow, but perhaps they are not, when we're talking about other things like a trichogramma, for example, that has low % efficacy, is really good, but you need to consider that is part of the integrated pest management. All of these botanical compounds is the same also. Here say, kindly don't recommend chlorpyrifos, which is phytotoxic to maize pain. Yeah, I mean, it's all the set of the tools, but I just mentioned even chlorpyrifos.
دكتورة ليلى. دكتورة ليلى سؤال؟
السلام عليكم.
عليكم السلام ورحمة الله وبركاته. حضرتك اتفضل.
بسأل سؤال، هل في طرق مؤكدة أو مجربة للوقاية من الآفة؟
David, did you get that one?
Yeah, but I didn't hear the English translation. Could I continue reading in the chat?
Yep. Yeah, David.
Yes, Ahmed.
Yeah, have you ever find any effective treatment for the whole armyworm?
Any treatment? What do you mean, any treatment?
David, did you hear that one?
No.
No, okay.
You can repeat, please, so I can understand the question.
Did you get that one?
Yeah, no.
They asking about is there any effective treatment to suppress the population of the fall armyworm in your work?
I think
for
that
protection. For protection.
Yes.
I think that is difficult. No, I mean you detect the infestation and you perform a trimming if it's necessary. I heard yesterday the talks about the suppression using steroid technique. My first job in Mexico was in a laboratory that we produce 1 billion flies per week, Mediterranean fruit flies, and we release in the field. But this is like a brute force, no? If we detect one fertile fly in the field, we release 1 million sterile flies around.
صوت واطي قوي.
But I think that has to be an approach. Unfortunately, I don't think that is something like it depends only in pesticide is going to be a situation. No, that is you can pay back with resistant developments or other effects. No, and also at least I see in Mexico and other Latin American countries in Ecuador.
غير تطبيقية يعني لسه.
Very narrow profit. So corn didn't pay too much. It's not like a crop like a tomatoes, other high value crops. So there is a thin profit. So for the farmers, maybe in Egypt is different, but the thing that I see in Latin America is very thin profit, and then sometimes the measures that you are going to take are going to be very expensive.
Okay, David. Any other questions?
There is no effective method for prevention, otherwise we would have it in all countries. And then, let me see here in the chat. Thank you. What about that being increase in resistance ratio for the amides once a time for 2018, 10 to 160 in 2019? Well, this work was in Puerto Rico, and we found very highly resistant ratios to fluindamide, and despite the question from Dr. Ibrahim, there is no use anymore in the work. But anyway, it was used in the past, and then was no use anymore, and they use chlorananthraquinol, but it's crop resistant. No, still you can control, but you see you can have certain level of control, but you can see the leaves, the external leaves, that they are damaged, no? And if you compare with the numbers of survivors, when you apply control for armyworm, you cannot. It's very hard to say you have 100% control, because you can miss one plant and then there is survivors. But in this case, with the chlorananthraquinol, we start observing more survivors. So some of them are resistant. No? Yep. But then when there is rotation, you will have survivors, and then in the next spray, when it's needed, spray other type of pesticides. So that must still the development of resistance. No, you think that everything is working well.
Yeah. Okay, folks. There's no any other questions? Anybody?
You can email me if you want also.
Yeah, we will do. Yeah, we will do.
And thank you so much for the invitation.
Thank you so much. Yeah, you bet. You're very welcome. I think you did a good job today, David, with us.
Oh, thank you. Thank you. It is my pleasure. Actually, I met some Egyptians in my laboratory. People, great people from Egypt.
Yeah, I think that's really lucky people.
Yeah.
Yeah. Okay.
Thank you.
Okay, Ben. Thank you so much.
Have a nice day. Bye.
You too. You too. Bye-bye.
Bye-bye.
Now let's move on to our next speaker. I think Minali Casey. Are you here around? Minali Casey. So Adini, are you here? Okay, guys, well, I think we will be waiting for the next speaker. So we have like 5 minutes waiting. Thank you so much, Daphne.
Thank you. Thank you.
Bye. Yeah, I'm here. Finally, I'm here. Okay, you can hear me now. I think we need to be waiting for Casey, Minal Casey. I'm looking for Adini from Brazil, if here around. Okay, Mr. Said, is Minal Casey here around? Is not here. Or Adi de Freitas Bueno from Brazil. Adini de Freitas Bueno. اوكي مستر سعيد، ممكن تعمل امير للدكتور ابراهيم الجبوري، عايز يقول حاجه. دكتور ابراهيم الجبوري، ممكن تفتح المايك له؟ استاذ منصور.
شكرا دكتور احمد. الحقيقه انا يعني ردت اعلق في الشيء، استغل هالوقت هذا. يعني اولا اشكرك واشكر كل الكوردينيتور اللي يعني كانوا مسؤولين عن تنظيم هذه الورشه. اشكر دكتور احمد عبد المجيد. الحقيقه انا حضرت، انا كل اسبوع احضر يمكن 3 ورشات او ورشتين يعني حسب الظروف. يعني ذاك اليوم حضرت ورشه الساعه 4 صباحا مع اجرو اسيا. فأمانة أنا شفت الورشة هذه قدمت معلومات، يعني معلومات كثيرة ومعلومات مهمة للحضور. فأنا أريد يعني أشكر باسم الجمعية العربية لوقاية النبات، أنا كرئيس جمعية أشكر يعني المنظمين والقائمين على هذه الورشة. يعني الحقيقة الورشة قدمت معلومات كثيرة للحضور، وأيضا يعني قدمت أفكار ممكن نستفيد منها إحنا. يعني آخر محاضر مثلا حكى لنا على المقاومة وأعطانا الحقيقة كيز أو إلمنت ممتازة للريزيستنس بيست.
دكتور دافيد
يعني شاران أعطانا معلومات أيضا عن تطور الحشرة وإلى أن وصلت. فأنا الحقيقة يعني مسرور جدا إنه عدد الحضور البارحة بلش ب 250 وانتهى ب 354 وانتهى مرة ثانية. طبعا رجع. أنا كتبت اليوم للنشرة الإخبارية للجمعية العربية لوقاية النبات يعني جزء من التكست عن الخبر هذا، وخليت كنت أتمنى في صورة الناس كلها موجودة. للأسف يعني آخذ من الشاشة بس ما شفت الناس كلها مطفية وقاعدة على جنب.
كل الشكر لحضرتك طبعا.
يعني كنت أتمنى يعني فالحقيقة باسمي أنا وباسم الجمعية وباسم إخواني زملائي اللي موجودين معنا أيضا بالورشة، يعني ورشة ناجحة بامتياز وبهذا العدد الكبير. يعني الآن أنا جاي أشوف 263. دكتور ماجد يعرف أن دائما نحضر مع الفاو. يعني الحقيقة عدد متميز جدا، وأتمنى أنه الناس اللي حضروا واستفادوا من هذه الورشة. وأنا أشكرك جدا أخي دكتور أحمد أنه سمحت لي المجال. صار لي ساعة أقول أعطيني مجال شو أعلم.
لا أنا والله المشكلة عندي أنا كمان، اللي هو الميوت والأن ميوت مش عندي أنا، مش عارف.
يعني هذه
فاحنا هي
زينات يعني تعلق، يعني زينات من لبنان ايضا حقيقه حاضره من زمان من اول يوم، وكانت يعني ناس في من تونس. يعني امانه حضور من كل الدول العربيه.
انا
يعني
شفت اكثر من حد
يعني
كمان من الاردن
دكتور احمد عبد المجيد عملها بامتياز، وعملها يعني بحرفيه. وطبعا اكيد الزملاء يعني دكتور حسن ضاحي حضرتك الاخرين اللي يعني انا اشكركم جدا. بارك الله بيك. والان اعمل لي ان ميوت حتى خلص.
احنا اللي بنشكر حضرتك، بس مش انا اللي بعمل ميوت وان ميوت للاسف.
يعني انت خلص خلصنا.
والله مش انا اللي بعمل ان ميوت، لو انا اللي بعمل ان ميوت كانت المشكله اتحلت. احنا كمان انا شايف كمان ناس كتير رافعه ايديها وعايزه تتكلم وعايزه تسال، لكن مش انا المتحكم في المايك. دي المشكله. حتى المايك بتاعي ساعات بيتقفل عليا انا شخصيا.
يعني الشخص من البرازيل يحضر ما يحضر لانه الوقت عندهم اعتقد الان.
ومعنا الدكتور حسن ضاحي اهو، يعني تقريبا بيتكلم بس الصوت بتاعه انميوتد اهو.
اعمل له،
يعني
خليه يعمل له منصور انميوت.
تقريبا هي مشكله في
لا بس احسن.
السلام احمد، معك
أيوة.
منصور من التنظيم.
ايوه
حضرتك
اتفضل.
دلوقتي سمح للحديث باي من الزملاء.
خلاص اسمح لحسن ضاحي.
خلاص الدكتور حسن ضاحي، الدكتور حسن ضاحي موجود عند حضرتك. He raising his hand physically.
يمكنك يا دكتور احمد الان تسمح له بالحديث.
حاضر. تمام. دكتور حسن خاصيه جاتني دلوقتي ان انا افتح. اتفضل.
الحقيقه يعني بنشكر كل الزملاء اللي شاركوا في الورشه، وبشكر استاذنا الدكتور ابراهيم الجبوري على الكلام الجميل اللي قاله في حق معهد بحوث وقايه النباتات. وطبعا اي ورشه اي شغل بيبقى فيه يعني شويه تقصير تقني، ولكن يعني ان شاء الله باذن الله معهد بحوث وقايه النباتات في المرات القادمه يعني في رجاله ونقدم حاجات افضل وافضل كتير يعني. وتحياتي للجميع وببارك
ان شاء
للدكتور
الله يا رب. ان شاء الله.
اخوه الزملاء القائمين على تنظيم العمل، وبشكر استاذنا الاستاذ الدكتور ابراهيم الجبوري، وبقول له عايزين نشوفك في مصر ان شاء الله
قريبا
ان شاء الله،
عشان ناكلك كشري يا ريس.
ان شاء الله. حد عايز يتكلم يا جماعه؟ انا شايف ناس كتير رافعه ايديها. من
دكتور احمد انا راح اسالك، هل راح توزع البرزنتيشنات على الناس؟ هل يعني
اي ثينك ديت في يعني في ستريمينج على اليوتيوب للحدث كله، وبتهيألي بعد ما بيخلص بيتعمل له ابلود ممكن تشوف. بتهيألي يعني.
ممتاز.
في ميس ناور.
انا اقفل الكاميرا عشان ايه اخد راحتي. هم اللي يجوا في الاخر يحلوا كده يروح معانا الدكتور احمد المنيب الدكتور تعليم وشرفنا بالحضور السيد فخام السيد رئيس الجمهوريه وما عملش حاجه. مايك مفتوح ولا حاجه؟
جميعا يعطيكم العافيه. شكرا لجميع المشاركين والمحاضرين، معلومات قيمه، ورشه رائعه جدا. انا جدا استمتعت منذ امبارحه ولحد هذه اللحظه واستفدنا جدا. ما بعرف، انا تفاجات ما كنت رافعه ايدي لاتحدث، بس كونك قدمتني فحبيت اشكركم جميعا.
كل الشكر والتقدير لحضرتك. شكرا.
يبدو البرازيلي ما اجى يا دكتور احمد.
منتظرينه. طب مينال كيسي are you here around؟
جزء اخذت النومه.
تمام. I can see دكتور ماجد. عايز تقول حاجه دكتور ماجد؟ افتح المايك. حضرتك اتفضل.
لا طبعا كل الشكر للدكتور احمد والمجهود الرائع والتنوع الغير طبيعي لبرنامج الورشه، يعني اللي بيغطي تقريبا البرنامج الكامل للمكافحه المتكامله لدودة الحشد الخريفيه. مواضيع اكثر من رائعه، متحدثين من اكثر من مكان، خبرات كتيره. نتمنى ان يكون في النهايه توصيات، التوصيات ديت تنفع انها تطبق تحت الظروف المصريه، واظن ان ده الغايه من الورشه يعني. وانا شايف ان معهد بحوث وقايه النباتات بيلعب دور رائع يعني بصراحه. ورشه كويسه جدا 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 جدا، واتفق مع الدكتور ابراهيم طبعا على المجهود، لكن الاروع ان احنا نشوف في الاخر فعلا توصيات ويبقى لها امباكت بعد نهايه هذه الورشه. فأشكر القائمين دكتور أحمد عبد المجيد والدكتورة نهى وكل الزملاء من معهد بحوث وقاية النباتات، وده مش غريب عليهم طبعا. المعهد بطبعه واضح يعني إن هو يقود المكافحة والمبيدات في كافة الآفات الحشرية يعني. فكل الشكر تاني مش عايز أكرره يعني، إحنا شهادتنا مجروحة فيهم يعني، لكن أنا شايف إنها ورشة مفيدة جدا، والأفضل إن لو يستمر أثرها لما بعد إن يطلع منها توصيات سواء لمصر أو للإقليم ككل، الناس تستفاد بالمعلومات اللي هي اتعلمت بيها. شكرا دكتور أحمد. ويا ريت حضرتك تكون أنت المتحكم از كوردينيتور ولا فاسيليتيتور.
لسه التقنية لسه جاية دلوقتي لسه.
التقنية دي كانت من يومين فاتت المفروض يعني، لأن ناس كتيرة جدا عندها أسئلة، ناس كتير حبت إن هي تشارك، ناس إنها تشارك خبرتها، وده مهم جدا الانتراكتيف كونكشن بين المحاضر
بالظبط وهي دي الديسادفانتج بتاع
زي ما عنوان الورشه بيقول يعني ان هو تبادل للخبرات يعني. فنتمنى من الان وصاعدا تبقى الامور منظمه. كحضرتك ككوردينيتور كل الناس اللي رفع ايديها لسه لحد الان يعني في بعض الزملاء رافعين ايديهم، فنعطي لهم المجال والفرصه ان هم يشاركوا.
لا هم ما ينزلوا الايد يعني. هي
اللي اترفعت يا دكتور ساعتها فضلت مرفوعه من ساعتها، فهم لازم يعملوا
نفس الكبسه له هاند يعني ما
بالزبط.
بس حسب الظروف. على كل انا اتمنى ايضا نسوي شير اذا عندك طبعا اذا عندك الايميل والاسماء يكون عندنا شير موجود للكل، حتى على الاقل ايضا يصير مثل ما قال دكتور يعني ماجد يصير تداخل بين الاخرين يعني بالايميل على الاقل الحد الادنى يعني.
تمام
لازم
تمام.
كانت اذا عندكم ليست اوف بارتيسيبنت فيكون يعني سهل انه يشير ويا الاخرين.
ان شاء الله we will take it in our consideration دكتور ابراهيم ان شاء الله.
وانا انتظر لانه عندنا النشره الاخباريه تصدر خلال الايام القادمه، فانا بعثت الدكتور احمد اللي كتبته شويه فاتمنى تكمل لي عليه يعني. وعدد انا كتبت يعني عدد الحضور وعدد شيء، بس يعني انتظر الجواب عاجلا يعني اتمنى
ان شاء الله ان شاء الله. والجميل في الورشه وجود حضرتك والدكتور ماجد والناس كلها. مش عايز انسى اسم حد،
الكل اغنى،
مش عايز انسى الاسم بس والله
بالعكس اغنى. والورشه كل الناس شاركوا الحقيقه، وناس فيه طبعا موجوده، بس يعني كان بودي صوره للشاشه كامله بها ناس، عسى انه تقول لهم يطلعون وجوههم
ان شاء الله.
دكتور احمد اللي موجود رجاء يفتح الكاميرا دقيقتين حتى ناخذ صوره للشاشه نحطها بالنشره الاخباريه
ان شاء الله. خلاص يا جماعه، طب هم سامعين حضرتك، كل الناس سامعه حضرتك
خلي بس
اللي يقدر يفتح
انا بدي صوره يا دكتور وائل، يا دكتور وائل والله بدي صوره.
ممكن تعمل حضرتك جاليري فيو هتجيب كل الناس يعني.
بس انا ما بدي جاليري، بدي الصوره الاولى
ما هو جاليري فيو للناس كلها حضرتك.
كيف اجيب جاليري فيو؟ والله
في الفيو، في الاوبشن بتاع فيو في على اليمين فوق
عندي يعني بالهاي الفيو. طيب شو اعمل؟
في جاليري فيو، في سبيكر فيو.
طيب هذا جاليري فيو.
جاليري فيو هيجيب كل الناس، مش كلها لكن هيجيب اللي هيقدر يجيبه من الشاشه على حسب الفول سكرين.
والله ما تحرك نفسهم. راح اخذها خلاص. اهم شيء انت موجود.
anyway ربنا يخليك دكتور. anyway احنا في انتظار المتحدثين
يبدو ما موجود، ما يعني ما اعتقد راح يجي هذا الرجل.
خلاص.
وسام الجبالي رجع. وين راح وسام الجبالي؟
هو قدامه 5 minutes ان كان، فممكن ندخل على حسب.
لا حول ولا قوة الا بالله.
احنا كان خبر ان هم موجودين حقيقي.
يعني البارحة الغداء راح علينا، اليوم الغداء راح علينا، والصلاة راحت علينا، يعني شو نعمل لكم؟ يعني كل شيء ما
كله في سبيل خدمة
في سبيل
الفول ارمي وارم. الفول ارمي وارم.
ان شاء الله كتابنا راح يطلع يعني. دكتور ماجد معانا، انا ودكتور ماجد سائر.
في عندي
الكتاب عند الفاو يعني ان شاء الله يكمل. ما اعرف دكتور ماجد يمك الكرة في ملعبك.
ان شاء الله
راح يوصلكم الكتاب مجانا. كل الريفيو يعني. الشخص اللي لقى اليوم شاران، انا كل الريفيو اللي ماخذ طبعا ماخذه من عنده، ايضا قسم كثير من عنده. هذا الرجل اشتغل اول ما دخلت الحشره. اول ما دخلت الحشره الى كرناتيكا بالهند، هو كان اول المتصدين لها واول واحد نشر النيو ريكورد. فامانه يعني كلهم بلشت الشاشه تنملي. يا الله رشا، حط شوي ضوء يا رشا. صور لي انت طيب يا دكتور احمد. انا ما طلع عندي هذا انا ما طلع عندي اللي قلت عليه انت الجاليري.
حضرتك شوف الفيو اوبشنز.
والله حطيته ما يطلع عندي.
هيجي زي مربعات كتير جنب بعض كده.
ما يطلع، ما في. هاي فيو اوبشن، هذه عندك جاليري فيو، اكبس عليه ما طلعش.
الجاليري
بس احنا وبس هذا اللي لو يبطل ما يكتب شات. بعدين اكو عندك كيو اند اي، ليش ما تشغلون تفعلون الكيو اي احسن ما يكتبون على الشات؟
اللي هم يبعت سؤال، يعني يطلب سؤال ويبعته. ايوه انا عارف التقنيه دي
طبعا على الكيو اند اي بدون ما يكتب على الشات وكل ساعه السلام عليكم وقطع المحاضره وترى هاي الشخبطه اللي يمكن دكتور قبلك حكى على الشخبطه هي عباره عن قلم تحت بالبرزنتيشن.
حد خده وعمل، ايوه حد خده وعمل، ايوه
لا ما له علاقه، ما له علاقه، هذا هو نفس المحاضر. بالزاويه اليسرى في عندك يعني 3 نقاط بس.
لو حضرتك كنت تواصلت معنا كنا بلغناه بقى كده. انا قلت
يعني
دي حاجه اوبشن، حاجه حد عملها ومش عارف.
ما يقدر واحد يعملها، كيف واحد داخل؟ بس هو في تحت موجود قلم اذا تريده، يعني ليزر، واذا تريد شخبط
لايتر اي
شوف.
في حد عايز
دكتور ماجد يحكي. دكتور ماجد يمكن.
دكتور ماجد لحظه واحده. اقبل حضرتك.
دكتور احمد عبد المجيد طالب الكلمه يا جماعه. دكتور احمد عبد المجيد
وينه؟ ما موجود. وين احمد عبد المجيد؟
كان طالب الكلمه حالا.
السلام عليكم.
عليكم السلام ورحمه الله.
أنا بس بحب إن أنا أشكر الجميع، وأنا في غرفة العمليات المفروض اللي عاملينها في مجلة المعهد، في معهد بحوث وقاية النباتات، عاملينها غرفة عمليات. ففي الأستاذ في الترجمة بنشكره، وبنشكر جميع الزملاء اللي موجودين في القاعة اللي شغالين. أنا عارف إن في بعض التقصير أو القصور، بس إحنا أهو يعني بنحاول مع النظام الجديد في ورش العمل والمؤتمرات، طبعا نظرا للظروف الحاليه، فبنتعلم مره في مره ان شاء الله كده اوجه القصور ان شاء الله نتلافاها. ارجو ان احنا نكون بنستمتع في المقام الاول بالماده العلميه. اعتقد ان احنا بنستفيد كلنا، ونتمنى ان شاء الله انها تكون ورشه مفيده علميا نطلع بيها بالفعل زي ما الدكتور ماجد والاستاذ الدكتور ابراهيم بتوصيات نستطيع من خلالها ان احنا نقدر مش هنقضي على الآفة، ان احنا نسيطر على الآفة. فانا حبيت بس ان انا اعمل مداخله، وانا زيكم هو مشكله في ان انا ادخل، بس الحمد لله يعني سمحوا لي مع ان انا في غرفه العمليات نفسها.
بس دكتور انا كتبت لك قبل الندوه، قبل الورشه، كتبت لك قلت لك انا حضرت الاكارولوجي بالجامعه اللي هو عندكم. امانه الكواليتي شتان بين هذا الكواليتي وبين الاكارولوجي ورك شوب اللي صارت في جامعه القاهره قبل يعني كم يوم. يعني بالرغم من بعض الانتربشن اللي صارت، بس والله هذه يعني ممتازه، يعني مفرحه.
انا فرصه ان انا اشكر استاذنا الدكتور ابراهيم الجبوري على النصائح الغاليه الهالي قبل بدايه الورشه حتى.
فيعني بعثت لك الان، بعثت لك على الواتساب اللي كتبته بالنشره الاخباريه حتى تكمل عليه، بس ما تخليني بالشحن.
ان شاء الله باذن الله دكتور ابراهيم، باذن الله. وان شاء الله كده نستكمل فعاليات الورشه وتكمل ان شاء الله على خير باذن الله. كل التوفيق.
اتمنى نكايه بالاخرين حتى تعمل كويشنير وتوزع على ذول. الدكتور ماجد يضحك.
ان شاء الله ان شاء الله. شكرا لحضرتك جميعا.
انا متاكد يعني يكون رائع الكويشنير
باذن الله ان شاء الله. شكرا لحضرتك.
خلاص حل عنا ما في بعد.
شكرا دكتور احمد.
الله يسلمك.
اديني are you here؟ اديني بوينو.
والله لا بوينو ولا موينو، ما في حد. هذا نام الساعة كم بالبرازيل؟
والله دكتور اديني قال هيجي، يعني قالوا انه موجود، بس مش عارف حتى هو لسه مش اونلاين.
55
مش ظاهر عندي اونلاين. هو تواصل معانا بالبرزنتيشن بتاعه باوربوينت. لكن هو مش موجود. ف 2 minutes دكتور إبراهيم.
يعني المفروض عنده دنيا الصبح، يعني الصبح عنده 9:30 إذا هو ببرازيليا ولا ما أعرف وين، يعني عندهم مفروقات بالزمن. دكتورة سلوى. دكتورة هاجر، ما في يعني. حسام صالح، شادي، ما شاء الله. حسام الجبالي، قائد المقاومة الحيوية، المكافحة الحيوية.
في انتظار البديل لآدني.
شو احنا مثل اليتامى قاعدين يعني نستنى. دكتور ماجد زي اليتامى احنا قاعدين. حقيقة فاتنا يعني حضور براسانا كان يعطينا تصور كامل عن البلانت ريزيستنس والأصناف المقاومة. يعني للأسف ما حضر، ما أعرف هل اعتذر ولا لا. يعني عنده توليرنت، خلينا نقول توليرنت، ما نقول أصناف مقاومة. دكتور ماجد يعني فالآن في يعني على الأقل 3 توليرنت الآن تختبر في أفريقيا حسب علمي، في كينيا وبعدين زامبيا، وحسب ما دكتور ماجد يخبرني يقول انه يعني ليست على ما يرام او على ما يرام، ما اعرف. بس بشكل عام يعني التوليرنت فرايتيز اللي بين ديسكفرد او يعني بريدد ان بمنطقه طبعا بالسمت في اللي هو المركز الدولي، فهذا كان يتحدث عليه براسانا، بس للاسف يعني ما حضر. على كل في الأفارقة الآن يعني يعتقدون أنه أيضا في بعض الأصناف اللي ممكن، أنا ما أعرف دكتور أحمد ممكن تعمل أنميوت الدكتور ماجد على الأقل، خلينا نتناقش إحنا ببدوة الحشد. يعني أنا بدوة الحشد الآن أنا بالأردن ساكن، أمانة دودة الحشد غزت الغور من الشمال إلى الجنوب بفترة قياسية جدا يعني، والآن الإصابة بالحقل الإصابة تكاد تكون يعني 100%.
دكتور
يعني
ابراهيم حضرتك طلبت الانميوت لمين؟
الدكتور ماجد اللي راد يعلق على
لحظة.
على براسانا، طالما هذا ما جاي على الاقل ننتظر شويه وتطلق سراحنا.
تمام. بس نشوف مين المحاضرة الأخيرة دي. دكتور ماجد يقدر يتفضل.
وفي خاصة البلانت ريزيستنت للفول ارمي وورم، احنا كنا عاملين ويبينار خاص بهذا الموضوع دكتور ابراهيم من الاسبوع اللي فات، وبيرسانا قدم فيه كل الفيو بتاعه، وممكن ان شاء الله احنا لسه يعني الفيديو بتاعه هيشارك ان شاء الله قريبا، يعني هيكون متاح، واظن ان هو هيكون فيه كل المعلومات المتاحه. حاليا في 8 فرايتيز في السمت بتختبرها في كينيا، مش 3 يعني، والنتائج بتاعتها مبشره. طبعا كل الفرايتيز دي عباره عن كونفنشال بريدنج، ما فيش فيها اي حاجه جينيتيك موديفايد او بي تي او بس طبعا زي ما احنا عارفين ان البي تي طبعا الافكت بتاعه هو الافضل والاحسن، وزي ما سمعنا من المحاضرين امس 98% من الذرة اللي بيزرع في القارة الأمريكية حاليا هو بي تي كورن. فبالتالي السؤال اللي بيتردد دايما هم بيعملوا ايه كأمريكتين عندهم فول ارمي وور من زمن بعيد يعني، لكن هم عاملين ايه دلوقتي؟ فجزء كبير بيرجع طبعا ان الفرايتيز اللي هم بيستخدموها طبعا موديفايد، ودي ابروفد عندهم، ما فيش عندهم مشاكل، زائد اللارج سكيلينج صعب فيه الانترفنشن كتير، يعني ان هم يعملوا بعض التدخلات اللي ممكن تكون صعب تطبيقها على المستويات الصغيره زي السمول هولدرز اللي عندنا، اللي عنده فدان وقيراطين ومساحات صغيره. ممكن ان احنا نوصي ببعض المكافحه الزراعيه، المكافحه الكيماويه زي ما هاريسون قال امبارح، لكن في الامريكتين بيعتمدوا بشكل كبير على الريزيستنت فرايتيز يعني. فالمعلومات دي هتكون متاحه. للاسف احنا ما كانش قادر ان هو ينضم لينا النهارده يعني، لكن المعلومات دي هتكون متاحه للاطلاع لو دكتور ابراهيم يحب يطلع عليها يعني.
شاء الله.
طبعا برضو نحب ننوه، لان انا معايا سؤال من روبرت اللي ادانا البرزنتيشن امبارح من المونيتورنج على الفاسيلتيز لانتاج البايو ايجنت والترايكوجراما بالذات يعني. فطبعا المنطقه مميزه جدا عندنا في موضوع الترايكوجراما، مصر مميزه جدا، عندها فاسيلتيز كتيره جدا جدا لانتاج الترايكوجراما. والفاسيلتيز ديت لو اتعمل لها صيانه، معانا الدكتور حسام الجبالي يكلمنا عن الموضوع بشكل اوضح. لكن انا شايف ان الاقليم كله مهيأ بشكل كبير جدا لتبني البيولوجيكال كنترول، لان دي من ضمن الحاجات الممتازه جدا اللي على اللونج ران هتثبت ان هي افضل من البيستيسايد. طبعا اللي ملاحظ حاليا في موضوع الفول ارمي وورم ان بتقدم السنين الآفة بتكون استابليشد، بيبدأ في حال الإدارة الجيدة ليها وعدم الاستخدام المكثف للمبيدات بيبدأ زيادة الناتشورال انمي، ودي حاجة طبيعية جدا. أي بيست لما بتدخل ما بيكونش معاه الناتشورال انمي، وانس ان بيحصل ناتشورال بالانس مع الناتشورال انمي مع الآفة دي بتكون مستوطنة وبتبدأ تكون يعني تحت الايكونوميك ثريشولد، unless ان يحصل اي ظروف تكون مفضله لدى الآفة فيبدا يحصل الاوت بريك. ومن هنا كان مهم جدا موضوع المونيتورنج اللي احنا لازم نفضل نقول مره واثنين وثلاثه واربعه. المونيتورنج ماهوش رفاهيه، المونيتورنج مش شيء احنا بنعمله وما بنعكسش على الحقل. المونيتورنج دوت هو عباره بالظبط عن النافذه الاماميه للقاطره، من غيرها مش هنقدر نسوق ولا او نقدر نعمل اي اداره جيده لاي آفة يعني. فده مهم جدا، واهم حاجه ان احنا نشتغل على السترينث بوينت بتاعتنا. طبعا معانا الدكتور عبد الفتاح عامر، يعني واحد من الناس اللي خاضوا الحرب ضد الفول ارمي وورم في بدايتها. شرفنا امبارح والنهارده طبعا ان انا ارحب بيه. كان شغال مع افريكان يونيون وعملوا شغل كبير جدا في افريقيا. لو في مجال ان هو يتدخل ويدينا من خبرته يعني هتكون حاجه جيده جدا يعني.
شكرا دكتور ماجد على التعليق بتاع حضرتك. سامعني دكتور ماجد؟ دكتور ماجد
عملت انا ميوت.
لا ما عملتش والله.
جوز منصور عملها نكاية بيك.
لا يعني كويس ان حضراتكم سامعيني يعني. والله برضو انا يعني رايي المتواضع في الفول ارمي وورم واي انفيسيف او انفيدر او اي آفة جديده بتخش اي مكان، ان احنا التدخل السريع لمجابهه الآفة دي ممكن يزيد زي ما احنا بنقول ماضي دوار او يزيد من الطينه بله. فانا كان رايي المتواضع في وجود يعني احنا عندنا مثال شهير جدا في الولايات المتحده الامريكيه، الشوجر كان ايفيدز او الميلاني ايفيز سكاري. الميلاني ايفيز سكاري او من قصب السكر كان آفة خطيره على قصب السكر في الولايات المتحده الامريكيه وامريكا الشماليه. بعد كده الناس يعني مساحات القصب قلت زراعتها، فبدأ هو يحول من الاستراتيجي بتاعته وينزل على السورجم او يجي على السورجم، مع انه هو ما كانش آفة على السورجم. فبدأ طبعا المزارعين يكافئوه لانه كان بيعمل لهم مشاكل في الهارفستنج، في الحصاد بتاعه، لان بيعمل ندوه عسليه وبيجي على الهيدز بتاع السورجم ويعمل مشاكل كتير. فبداوا طبعا الولايات المتحده عندهم مستر ماكسيمم ييلد، يعني عايزين الييلد العالي. فطبعا بيحاولوا ان هم يستخدموا المبيدات او يستخدموا البدائل او يستخدموا اي وسيله من وسائل المكافحه. فما زاد الشوجر كان ايفيدز الا فرارا، ان هو بدا ريزيستنس لمعظم المبيدات الموجوده، ان هو بدا يحصل التربيه والاطلاق لبعض الاعداء الحيويه اللي بتيجي في مكانها، وكانوا بيجيبوا مثلا الكوكسينيليد من الديابوز، من الاماكن بتاعه الديابوز، ويحاولوا ان هم يطلقوها. فبدا ان يحصل انتر كومبيتيشن وانترا سبيسيفيك كومبيتيشن بين الاعداء الحيويه، ويحصل خلل في الناتشرال بالانس كله، سواء كان باستخدام المبيدات بقتل البنفيشال انسكت اللي هي منوطه بمكافحه اي آفة، او انها ريزيستنت اللي بيقع على الآفة ويخليها تقاوم ضد المبيدات. فرأيي انا اي آفة بتيجي من مكان غريب بتيجي للمكان ده هي عندها فينوتيبيك بلاستيسيتي، عندها بلاستيسيتي عالية للمعيشة في بيئات مختلفة، عندها مدى عوائلي واسع، عندها حاجات كتير بتأهلها ان هي تيجي على اي نبات او تنقل منه او تجمع او بيلد بوبوليشن او تبني تعداد وتحاول ان هي تعمل استابلشمنت في المكان وتبقى مرحله جديده وسقطر لما هو اقرب زي اللي حاصل. فاحنا الرصد هو رقم واحد، زي ما الدكتور ماجد بيقول الرصد هو رقم واحد، هو الوسيله الوحيده اللي بتقول لي في دامج، في ثريشولدز، في خساره فعلا حقيقيه ولا لا. الاماكن اللي فيها بؤر للاصابه لابد من التدخل السريع بالمكافحه، يعني بالوسائل الامنه. اما الثريشولدز اللي هي يعني التعدادات المنخفضه اللي هي لا تؤثر او تكون اكسيدنتال او ما تعملش، فنضطر ان احنا نسيبها. اللي حصل في امريكا ان حصل ريكروتمنت لبعض الاعداء الحيويه. حضراتكم تعرفوا ان الحشره بتيجي للمكان وبتيجي على الهوست بلانت بتاعها، وبعد الهوست بلانت بتاعها ما يبدا يحصل له رياكشن معاها يحصل كو ايفوليوشن، فيبدا فولاتايلز معينه بتبدا من النبات تعزم او تدعو الاعداء الحيويه اللي موجوده في المكان التي تستطيع ان تتغذى عليها من الكارنيفورس الموجوده او البارازيتويدز اللي موجوده، زي ما حصل وجه اللايسيفليبس عندهم. لايسيفليبس طفيل المن.
هذا تحكي دكتور احمد على الروبولا سايفر؟ هذا
لا مش الروبولا سيفن بادي، لا انا بتحدث على الشوجر كين ايفيدز اللي هو الميلاني ايفيس سكاري.
اوكي.
فدلوقتي حاليا بعد 4 أو 5 6 سنين من التدخل بجميع الوسائل، حاليا هم سايبين يعني شالوا ايديهم من كل حاجه، والطبيعه دلوقتي هي اللي بتاخد مجراها. يعني دلوقتي سجلوا بعد كده بقى طفيلين عليها، وبعد كده في بعض الهارمونيا اكزيليدس بدات اللي هي الريجلان ليدي بيت بدات ان هي تبدا تتغذى عليها رغم ان هي ما كانتش تتغذى عليها، وبدا يحصل خفض للتعداد بتاعه. والوقت حاليا بعد ما عملوا بروجكت كبير لمكافحته، البروجكت ده دلوقتي حاليا يعتبر واقف او الفند بتاعه متوقف، لان دلوقتي الناس اللي بينزلوا الكاونتيز هناك ما بيلاقوش تعداد من شوجر كان ايفيدز. فانا رايي انا المتواضع ترك هذه الآفة للطبيعه والتدخل السريع في الاماكن اللي فيها كراودنج او الاماكن اللي فيها اوفر بريكس او فوران بس. واظن ده ما يمنعش الناس ان هي تشتغل عليها او ان هي تعمل عليها بيولوجي او شغل معملي او ان هي حتى يعملوا لها رصد او متابعه او سيرفي ليها وللاعداء الحيويه المصاحبه ليها. ده رايي المتواضع.
دكتور احمد الحقيقه الحشره ما ترحم هذه، يعني انا اسرع حشره، انا متابع حشرات كثيره يعني ايام التوته يمكن، بس هذه الحشره يعني انا تابعها بالاردن.
تمام.
امانه يعني لا ترحم. يعني البارحه
بيسموها ديستركتيف.
البارحه بالذات البارحه رحت بس دا اجمع، يعني علمت المزارع كيف يطلع لي البيض.
تمام.
فنزل للحق مباشره راح على البلعوم، على الورل هذا اللفه اللي بالنص، مباشره جاب لي البيض. يعني انا حاطه عندي هنا بالمكتب الان فقس البيض اليوم، للاسف ما لحقت افحصه.
ده توتا ابسولوتا ولا دي ارمي وورم؟
لا الفول ارمي وورم، بالعكس انا احكي على الفول ارمي وورم. يعني صح انت تقول يعني افريقيا من دخلت الفول ارمي وورم، يعني كان السلاح الاول هو الالفا سابرمثرين والسابرمثرين. قدروا ينزلون الاصابه بال 2016 2017 بدات الاعداء الحيويه تشتغل، يعني بلشوا يسوون السيرفي 2017
دكتور احمد المتحدث وصل.
المتحدث اوكي.
ابانا نروح نتغدى.
تحدث الله.
سكرني الان، انا راح اسكر نفسي.
صح يا جماعه نقدم يا مستر منصور، الاسم بتاعه مش ظاهر عندي.
السيد كيسي.
Okay. I think hi Casey, are you hearing me? Casey? مستر منصور، استاذ منصور.
Okay, now, hi, good afternoon, everyone. I can hear you very well now. I'm on mute.
Oh, hi, Casey.
Hi.
Okay. Our next speaker is Minali Casey, Principal Scientist and Head of Social Science in our National Center of Insect Physiology and Ecology, Nairobi, Kenya. And today he is gonna talking about the economic, food security, and health impacts of fall armyworm. So, Casey, are you ready? We're waiting for you.
Thank you very much. Thank you, Professor Shaban.
Okay, now you can share your screen and start up.
Let me see. But it says host disabled participants screen sharing. Can you able me?
Okay. Just give me a second. Okay, did you get it?
Yes.
Okay, go for it. Yep.
Can you see it?
Yep.
Okay. So,
yeah.
Okay. Thank you, Professor Shaban, for giving me this opportunity. I tried to put few slides, so just came to know this meeting on the third evening. But I don't want to decline because it's a very important meeting to share some of our findings here at ECP, at the International Center of Insect Physiology and Ecology, where the headquarters is here in Nairobi, in Kenya. So I will just talk briefly on the economic security and health implication of fall armyworm. Based on empirical evidence from Ethiopia, we have also done some work in Uganda and in Kenya, but today I will share you only the result that we found in Ethiopia. What is our objective is just to understand, like as I said, the cost of fall armyworm, economic security and health in Ethiopia. And what did we use? We collect data using focus group discussion from 30 districts and 150 villages. These are the dominant most growing regions or villages and districts in the country. And these villages, of course, as you all are aware, the impact of fall armyworm varies by agroecology. So we try to collect information across the various agroecologies of the country where maize is growing. So you can see the distribution of the 150 villages across five agroecology. The FPDG, the focus group discussion, we collected information from over 100,000 farmers. And then, of course, we combined this community data with the national representative household survey data collected by the Ethiopian Central Statistics Agency, especially to get information on maize area, maize production, which is very good to map it up to the different agroecologies based on the focus group discussions that we have. So I think the first thing to assess the impacts of fall armyworm, it's very important to know what is awareness and the knowledge level of farmers. As you can see it from this slide, 95% of the FDG participants or the farmers were aware of the fall armyworm. As you can see it from the figure, we asked them First, whether they are aware of fall armyworm or not. Then we ask a follow-up question, whether they can identify the fall armyworm from the picture that you see from the right. So as you can see, I think quite a number of farmers, they are well aware of the farmers. It's very important for implementing the right strategy, control strategy for armyworm, and also it's very important for accurate estimation of the impacts of fall armyworm on maize production. So this is the first thing we ask the farmers. And then this is based on this formula, as you can see it. We try to able to estimate the fall armyworm impact on economic loss, on maize production loss. So we take into account the average maize area, the average production loss. We ask the farmers directly the yield loss that they encountered as a result of fall armyworm explicitly. Of course, we also ask it yield loss as a result of other stresses like stem borer, drought, etc., but we explicitly ask it the percentage yield loss as a result of fall armyworm. Of course, to compute at the country level the loss of the impacts of fall armyworm, you need to know the number of maize growing households at the country level. And then, of course, all farmers may not be affected, so we need to be able to know the number of farmers affected. And then, of course, we estimated it by agroecology because we know the loss varies by agroecology for a number of reasons. Could be the vegetation, the rainfall, the temperature, etc. And then, of course, the farmers' management and characteristics also may differ by agroecology. So we estimate the data by agroecology. But here I'm going to present for you, as some of you might aware, Ethiopia is divided by nine regions, I think. So we focus only on those regions. The dominant maize production is coming. Almost 90% of the maize production is coming from these two regions, the Amhara region, Oromia region, the Southern nationalities people region. So what we did is we asked for 3 years of farmers since the fall armyworm invasion is started in the country. That's 2017, and then we asked 2018, 2019. So as you can see, the loss over the last 3 years is about 0.65. We estimated 0.65 million tons of maize production loss. That is every year, it's about 0.22 million tons per year. This is like 30% of the total maize production in the country. And then, of course, okay, if you converted this into value, it's about USD 200 million. The country encountered 200 million worth of maize production loss over the last 3 years. If you put this in a perspective, of course, the loss at household level seems is low because the per capita maize production loss is that the number of affected farmers that we estimated are about 3.7 million. So if you divide the 0.65 million production loss by the 3.7 million, every year, these affected farmers were losing 60 kg of maize per year per affected farmers. But despite it is at individual level, the loss seems small, but if you can look at it, the economics loss at a national level is very huge. It's under 202 million. This is without including other costs like the management cost, the chemical cost, the surveillance cost, the labor costs, etc. So if you include all those ones, actually, the loss is higher than, this is a direct loss. So if you're gonna include the indirect loss, the loss could be huge. Of course, this loss is still huge. It's equivalent to 0.08% of the country's GDP over the last 3 years. And then if the 0.6 million production loss, actually could have met the major requirements of 1.4 million people per year, or the total maize production loss could have met the major requirements of about 4 million food insecure people in the country. So this is really a big loss that the country is facing. Still, the problem is still there. Quite a number of farmers are still affected because the government's now diverted to, of course, controlling locusts. That is a direct loss that you see, but the fall armyworm really it increases the pesticide application in addition to the pesticide application for other insects like stem borer, now locust. You can see it, and then these are the 4 types of insects that the country is using. You can see it is quite a high number, quantity of volume of insecticides being used to control the fall armyworm. That's for, in terms of value, is 4 million. And then I think this quantity covers about 1.5 million hectares of land. But the question is fine, but still, okay, using this volume of insecticides, fine, but how effective they are is a question that we need to ask. Yeah, we are, the government is using, the farmers, of course, we didn't also here, I think it's good to note that we didn't include the quantity of chemicals being used by the farmers. The farmers also themselves, they purchase because they are desperate to control the insect, they buy their own insecticide, which is not included here. But the question we need to ask is, still we have a loss while applying this volume, this huge quantity of insecticide. I will come to that one. The data that shows some of the insecticides are not effective to control the fall armyworm. Here is maybe as a supplement and additional data that I would like to show you. The one that I show you, the chemical, is just at the community level, but we also collected information at household level to see how fall armyworm influence the use of insecticide use. So here we used close to 1,300 farmers. So you can see fall armyworm really increases or the quantity of fertilizer used by 38%. Let me see. Can I see it properly? Yeah. It increases the probability and the intensity of insecticide use by 13 and 38% respectively. Like as I said, the question we need to ask is, okay, it is crowdsourcing in insecticide use, but the question is are these chemicals effective or not? Is the question I think we need to ask. Maybe the following slides will tell you something related to the effect, whether the kind of control strategies the farmers are using, including chemicals, are effective or not. As you can see, the first column on the full sample column, you can see the control here, the reference group is where the plots are not affected by fall armyworm. So still, those who are not still using any strategies, they are losing, you can see a negative impact on maize yield. Even ash control to those plots is not helpful. Chemical, you can see it is not helpful, it's not mitigating the risk of fall armyworm. They try to use hard picking, but you can see it when they try to combine the different chemical control strategies, there is a possibility. Just looking at the second column, just look, considering all these the households affected by fall armyworm, just combining chemicals and then hand picking, you can see as a positive impact. And then you can see ash and then hand picking because it's a positive impact. What this shows us, what this tells us is the control strategies individually are not effective, but when we try to combine them, they seem to help the farmers in reducing the risk of fall armyworm. I think this makes sense. If the pest misses one of the strategy, it might not miss the other strategy. So here the question I think we need to say is chemicals will not help. That's why maybe we find that kind of huge loss. The chemical per se is not that effective in reducing the risk of fall armyworm, on the impact of fall armyworm. Here you can see also this bar graph where we asked in the community survey, where we ask them how effective are the different strategies on the scale of 1 and 10. You can see it's almost on chemicals. The farmer says it's effective. They just give a score of 6, which is almost not even a score of 8, score of 7, a score of 9, which means still the effectiveness of the chemical is less, which is in line with the household survey data. Here the result I'm showing you. So something has to be done. How either we need to use effective chemicals, or we need to find a strategy to make effective the chemicals that the government is spraying and the farmers are spraying. So here, using, I think as some of you might know, we use this the environmental impact quotient method to see how these chemicals really affect the health in terms of water leaching, direct exposure, and then the ecological in terms of killing birds and the beneficial insects and then others. So you can see those chemicals, they seem to be high toxic for the environment, but they are relatively less toxic for human health. So still, which means impact on this ecological effects, its long-term impact could be serious in terms of food security, because if we are killing the beneficial insects in the long run, this may affect the food security and the poverty status of individuals, and then the economic performance of the country in general. Okay, if the chemicals are not effective, here at ECP, we have a technology that we are develop and promote. I'm sure some of you might be aware of a push-pull technology. It is initially designed to control stem borer and striga. As the name push-pull technology, for those of you who doesn't know, this is a technology where you intercrop maize with desmodium, and in the boundary you put a grass called brachiaria grass. So the desmodium pushes the insect, and the brachiaria pull the insect. That's why the name comes from push-pull technology. So initially it was designed for stem borer, but later on we see farmers, they observe this technology also helps us to control fall armyworm. So we try to see the impacts of this technology using household level data, the 1,300 household level data. So here, I think what we observe, push-pull technology reduce maize production loss due to fall armyworm in the range of 28 and 30%. And then we can also see if it increases, of course, the impacts of fall armyworm, automatically it will increase the maize yield by 20%. But what we don't observe is, okay, if it reduces fall armyworm, still farmers are using more insecticide. Maybe this says it can be explained because the government is freely distributing insecticide. So we might need to create awareness in the plot where we have such kind of technology. We might not need to use more chemicals. So that's why maybe we don't observe the impact of push-pull technology in reducing the pesticide application in a plot where we have push-pull. So you can say it reduces maize loss, the first column, also stem borer, but you can see it, we try to use different specifications, but still the impact of push-pull technology on insecticide is not as significant, like as I said, because the farmers are getting the chemicals free, so maybe they don't care much. So what should we do? And the next step is, I think we need to develop and promote multifunctional, human and eco-friendly control measures to address really the impact of this devastating pest, especially at the national level, where we are safeguarding the environment and the health. I think what's lacking for us is we shouldn't always, condemn or blame chemicals. Chemicals, of course, they also increase the productivity. But the question is, if the cost benefit is the outweigh, that has to be assessed. But for that to be assessed, whether the chemicals are really, their benefit outweighs the cost, we need to understand the impacts of the chemical that as I showed to you, because there is no so far study the efficacy clearly by how much those chemicals are increasing the maize productivity. Once we know that, it's easy to show the economic cost to the society, so that we should be able to tell with confidence, look, if we use chemicals, it has a BCD benefit, but it has also a BCD cost. So the cost outweighs the benefit. So it's important, I think, our biological colleagues to do some efficacy study on the chemicals that are being used currently by the governments or donors. I think with this, it's important to acknowledge farmers, the European Union, and then NORAD who sponsored this program, and of course it should be Ethiopian team, not Ugandan team, and then colleagues who are leading the various projects, and the survey team, and the Ministry of Agriculture of Ethiopia. Thank you very much. It could be quick, but I hope you have got some information. Over to you, Shaban. Hello. Hello. Answer? Do you have questions or can see hand? Hello?
Yes, doctor. Do you hear me now?
Yes, I can hear you now.
Yes, sure. We will receive more questions now, but we're waiting for our coordinator.
Okay.
Who will be with us now.
Okay.
Okay, Adi, welcome back. Adi, are you hearing me?
Yes, I do.
Oh, yeah, thank you so much for that presentation. And now let's get started the discussion. If any of you guys want to ask. So I can see Dr. Ibrahim Japouri. I'll try to unmute you. Yeah. We're sorry for that. I think the option, there is something in the Zoom. So yeah, Dr. Ibrahim, you can accept and talk.
Can you please get out from your presentation, Mr. Casey? Okay, thank you very much. Thank you very much. It was very interesting. I mean, I have only one question. How you calculate the impact of, this is 4 or 5 pesticide you use, I think, by 5 pesticide, dimethoate, diazinon, and dorspan, and others. How you, calculate the effective on person, on people, or on ecology, on environment? I don't know, because do you consider the poisonous cases on human being or the farmers? And this is my question. Actually, it's very interesting, more economic in your lecture, but I mean, we have to think about these parameters. So please.
Okay. Yeah, thanks, Dr. Ibrahim. Well, I think there is this formula, a method called environmental impact quotient methods, where they provide you once you know the active ingredients, once you know the application rate, what you need to do is you plug those numbers and the volume, of course, the quantity of application rate. So you've plugged into that formula because they have a formula for consumers, they have a formula for workers or producers, they have also a formula for ecological effect. So you plug in those parameters and then you get the result for each ingredient, and you can aggregate that one to overall environmental impact question. So there is a formula that basically to
So you mean the dosage and prices and
no price, you don't need price here.
Application rate, or what is it?
The application rate, the active ingredient. What's important is especially the active ingredients. And then the application rate per hectare. Those parameters are critically important. But I think maybe if you look at, let me write it, maybe I'm sure you are, I mean, many of you are biological scientists. So if you just Google on this EIQ, environmental impact, just as a simple method, as long as you have those
because
parameters.
I have seen the dimethoate, for example, it's extremely high effective on the impact is very high on ecology and person and farmers. And
I think except the last one, I didn't remember it. I think many of them, I think. Okay, even under the World Health Organization.
The last one is the dimethoate.
Yeah, so the World Health, I think they are classified under the slight and moderately hazard impact. So I think they are, especially the response is really, I think it's very crazy. I don't know why they are using it, but
they are still use it.
Yes, toxic. It's good to use it. Yeah, it's good to use it properly.
Thank you.
Okay, thank you, Dr. Ibrahim. Any other questions? You guys have any other questions? Please raise your hand so we can find you. Is there any of you guys had any question? Let's have a look at the chat box. I think some people is typing.
Okay. You can read that for me.
No, I think there is no question here.
Hello.
Oh, okay. Dr. Amalika, okay?
Yes. I have two questions.
تفضل يا دكتور.
What is the method which measuring ecological effect? Ecological effects.
ممكن تعيدي حضرتك السؤال يا دكتورة؟ ما سمعناش.
Yeah, like as I said, as I responded to Dr. Ibrahim, we used environmental impact quotient method. Maybe I can share if you want the link. It's just an available method.
Yeah, would you please? Yeah.
This is a common method being used in the literature. Of course, it's not the perfect method, but still, because there is no alternative, it's a kind of method we are using. But I will Google and after the question and answer session, I will put the link. I will send the references. Probably you can do it right away. Okay.
Okay, we'll be grateful if you leave your link here as below.
Yeah.
Okay, guys. Any of you have any question? Is there any question or comments before we? Dr. Ibrahim again. Okay. Just a second.
Mr. Casey, since there's nobody ask you, then I will come again to you. Yes. I mean, you know, there is damage and injury. In corn, there is damage. I know that, of course, I'm teaching the push-pull technology, crop system technology, and it's very useful. It's very useful, and we are trying in Egypt to adopt such kind with, they use Fasulia alafia, I think that forage Phaseolus vulgaris. They use it also instead of Desmodium, but we are still looking for something instead of Bracharia. And it's still we have to have to adopt or to cooperate with the phytochemistry people like Khan, Mr. Khan. I know him, the guy who is the push-pull technology and Medega. I met them in Hyderabad. Really, I mean, the technology is very, very, very cool, very interesting, but we have to push for more effort in our area, in Egypt, in Syria, and I'm sure if the phytochemistry specialists cooperate with us, we can reach to very good plant as attractant and repel or attractant. Sometimes what I recommend, instead of attractant, we can use also pheromone trap. So the push, it will be the Phaseolus vulgaris in the case of Egypt, and the attract, it will be the pheromone trap temporary until we find the second choice. The second choice of as attractant plant. This is what we suggest for Egypt to try this technology. Meanwhile, there is also chemistry now. There is also some products from different companies. They are also using the attract and kill in another formulation, but they are still not succeeded yet. But there is trials also. I have many questions because it's more economy in this one. What do you think? Can I base my calculation on yield damage or on crop damage when I want to count in general the damage?
Well, thanks, Dr. Ibrahim. I think I'm happy to also know that you are teaching push-pull technology, and then you are trying to also use it in Egypt. I think that's very good. I think well, it's good if you can have also, I think we develop a collaborative project to promote this kind of technologies to various African countries. And then, of course, it's good to have a basket of technologies for the farmers. As long as they attract that, it could be a different technology, especially if it doesn't fit in Egypt. A replacement of a brachiaria, I think that should be possible because it has to be adapted. And then it's good to give options also to the farmers based on their cropping system, based on their environment. For the one you ask, whether we consider the yield or the plant damage.
Yes.
That's where I think in our case we asked only the yield, but I don't know what you mean by plant damage, the entire damage. I don't know. Maybe you can explain to that one. But in our case, we focus the yield damage. I think the plant damage, if you are referring to including the leaves, etc., the stem, etc. But what we observed is, I think one of the things even I was telling to my colleagues, I think we shouldn't exaggerate sometimes the problem because it's not entirely damaging the leaf. That the damaged leaf can be used as a livestock feed. By the way, it's not a total waste. It's not a total loss. We should be very careful because when we are reporting as if there is a total damage, but there is no. It's not necessarily total damage. The damaged leaf can be used as a livestock feed, especially in a country where the crop livestock integration is high, like the case of Ethiopia. Mm-hmm. So just to make the answer short, in our case, we use a yield loss, not the total plant damage.
Thank you.
But it's good to have always economics because at the end of the day, what matters is economics. So exactly. whenever you have such kind of meeting, I think it's good to engage I'm sure there could be many social science here.
Because this is the first time I heard somebody from SCP talking about, economics. This is always biology, ecology, biological control, So you
I
are
think
the
that's a
first
good
one
sign.
to-
Yeah, that's
yes,
a good
that is
sign.
a good, very good sign. This is
Yeah.
a very good sign. They
Yeah,
have too much money. They got too much money from international organizations, so they have to work in different aspects. Thank you very
Yeah,
much.
we have also done the economics of push-pull. Maybe I can share in a separate email if you can text me your email address. That also helps you maybe to teach your student as well.
Thank you.
اوكي دكتور ابراهيم لسه عند حضرتك اسئله؟
والله يعني انت ما عندك ناس ممكن
لا
أسأل.
لا اتفضل حضرتك تسال او
لا ما عندي خلص انا بالنسبه لي يعني اعتقد كفيت ووفيت.
تمام
اوكي
هذا اخر محاضر هذا اخر محاضر؟
لا لسه احنا قدامنا 5 دقائق وادي هيخش خلاص.
I can see
one more speaker.
I can see one question was an insect infestation recorded on cotton plant in Kenya. I'm sorry, I'm not aware of this one. Maybe it might affect, but I'm not aware of whether if fall armyworm really affects cotton plant.
Okay, so I can ask you something. By the way, as an economist, how could we mitigate the injury of the fall armyworm? So, as an economist, I think you touch the main point or the main way we can follow just to suppress the population. So, did you have that answer, specifically, or still under investigation?
Yeah, I think. Thank you. We have now developed some technologies. I think they call it ECP7, ECP64. As we speak, I have experimented in Uganda to see the effectiveness in terms of reducing the infestation of the pest, as well as its cost effectiveness. So we have those kind of technologies. I think that even like, as I said, the push-pull technology is one component, but I think it's good to have, like, as I show you, a combination is very important. One technology may not be 100% effective. So what we are experimenting as we speak is trying to look at biopesticides, the two biopesticides separately, and the push-pull separately, and then by integrating the two, how the effect looks like. I think now we are doing just a firefighting. The governments are doing a firefighting. Okay, that's expected because it's not good just to simply sit and see the pest is damaging. But I think now, started 2017, it's time to think now, to sit down and to see which kind of technologies can we use that can minimize the damage, while also not only the damage, the yield damage, but also the environmental and the human damage, I think.
I like your answer because, the collaborative work is, is a final solution for everything, for any problem will show up. So it's like pop-up problems, and everybody should be tying together and just make like a teamwork to face that pest. I'm also glad because you are economist here, as Dr. Ibrahim said. Economist here with us, I think it's something new, and you are very special guest with us today. From my point, I want to appreciate you. I think you did it so well, and you cover everything and even the discussion. So thank you for being with us, Casey, and we look forward to be with you again. Okay.
Thank you very much, Ahmed. Thank you for having me.
Okay,
may I, Ahmed, may I?
Okay, go for it.
Dr. Casey, I think the second lecturer is not yet arrived. Is that correct?
لا he's هو موجود معنا.
موجود معنا؟ خلاص إذن خلاص I will stop now.
Okay, that's
thank
fine.
Thank you.
Okay.
Oh, hey, bueno.
Yeah. Okay, guys. Adini, are you here?
Yes, I am.
Oh yeah. Hello, Adini. Good afternoon.
Hello.
Afternoon.
Okay. Okay, guys. Let's move on to our next speaker. Is Dr. Adni De Freitas Bueno, National Council for Scientific and Technological Development, Brazil. And Dr. Adney, he is a coordinator at Embrapa Soja Londrina, PR, CNPQ Research Productivity Fellow. And he's an associate editor of really good peer-reviewed scientific journal like CABI Agriculture. I can see here Nootropical Entomology, and I can see Bioscience Journal, Brazilian Journal of Entomology. And I think he will develop to talk with us today about the biocontrol of fall armyworm. Okay, Adi, are you ready?
Yes, I am.
Okay, go
first. I will share my screens.
Yep.
Here, share with someone. Are you seeing my screen?
Not yet.
Yes.
Yeah.
Yes.
Yep. We got it.
Okay.
Yeah. Go for it.
So first of all, thank you for the invitation. It's a great pleasure for me to be here to talk a little bit about Spodoptera, a really, I think, common enemy lots of nations has in common. So what I have prepared to talk today is about Spodoptera in Brazil. Not only the fall armyworm, but we have several other species. Of course, you have Spodoptera vegetativa, maybe the major species feeding on both maize and soybean here in Brazil. But you have some other Spodoptera species in this complex of species, such as Spodoptera cosmioides here, Spodoptera vidania, that I also would like to touch really briefly, because I think most of the management we need to have is concerned to all the species. So here you have my contact information, my phone number, my WhatsApp number, and also my email. So anyone can contact me if you need something from myself or also from Embrapa Soybean in Brazil. Since last year, I also the International Affairs Coordinator here in Brazil for Embrapa Soybean. So it will be a pleasure for me to take any doubts about Embrapa Soybean in my head. Just to show where you are, so we have here the map of Brazil in South America. Embrapa Soybean is located in the south. So Embrapa Soybean is one of the 43 Embrapa research units all over the country. And here you have research relates to soybean and also maize, because the same crop system, soybean in the summer and maize in the autumn and winter. Today, we are in a farm of 350 hectares. We have 62 scientists here in different areas. We are in a total of 270 workers. We have around 75 students, divided into master students and PhD students who also work with us. We have an institutional video that, if you have time again, I'll play for you. That it is in English and show a little bit more about the research we do here at Embrapa Soybean. I divide my presentation with a short introduction, talking about the different Spodoptera species we have here. Also about the importance of those species to, I will talk about soybean maize, that is the crop system I work with, but of course Spodoptera is also important for other crops in Brazil. But my research and how my experience is regarding to these two crop systems, that I'll be focus my presentation on soybean and maize in Brazil. And I try to give you an overview of this crop system.
Adney, excuse me, Adney.
Okay, go ahead.
Would you please don't touch your screen, because I think there is a pointer or something, and this stuff will not be erased. So Okay.
Okay.
That's fine. Okay, keep going. Sorry for that.
Okay. I will talk also about biological control. So both conservative biological control, and of course, we talk about biological control preservation in the field. We need to talk about IPM, the threshold, and how we can help the natural biological control to survive and act. And also talk about augmentative biological control. And our research here is focused, on egg parasitoids. Is there a way to remove that? Sorry.
The only way to remove it, to leave the meeting, then we will be back. So I don't know. It's up to you.
I don't think that's the. It is disturbing the presentation.
Exactly. Yeah, the same happened with other lecture before. So the only way we got, you need to leave the whole meeting, then rejoin again. So it's up to you.
Okay. For me, that's not a problem. If it's a problem for you, I can do that. But in order to.
Okay, I think you can keep going. It's not that, not that much bad. The four major species we have here, it is Podopteridania, Cosmioides, Frugiperida, and also Spodoptera albus. So we have this complex of species. All of them feeding on both soybean and maize. It's really difficult to separate the species. As you can see, the pupa, it is quite the same. Also the eggs, they lay eggs on egg masses, like you can see. The only difference is for Spodopteridania, where the egg is in an egg mass, but it is only one layer, while the other species will have multiple layers. What is much more difficult for the egg parasitoids to parasitize the egg masses. Spodopteridania is a single layer, and the egg is green, so kind of easy to separate the species. What happens in the soybean maize system in Brazil? That's the picture you can see on my slides. We have the first line of machine harvesting soybean, and the second line of machine sowing the maize on the second crop. So this multiple crop system, what makes is offer green plants to the pests. So it helps the outbreaks to occur, because you always have food for the insects. And as you can see, the Brazilian maps, the first one, we have the soybean area, and the other one maize area where it's cultivated. You can see that are pretty much the same area. So that's why we have soybean in the first season, coming with maize in the second season. That's what most of the time happens here in Brazil. It offers, of course, foods constantly, and offering food constantly helps the population to increase. When we analyze the biology of those species, we can see that the Spodoptera frugiperida, the fallworm worm, they have really good survival. That's the larva additive survival, feeding on different plants, on different hosts. And you can see that the insect is really well adapted to survive. And soybean, cotton, wheat, oat, maize having high survival in all of those crops. Spodoptera cosmioides and Eridania are a little bit different. They don't feed well on grasses, so they don't attack wheat, maize, but of course that's the major species occurring on soybean and cotton. When we study the position preference in field cages,
we saw that the Spodoptera frugiperida laid much more eggs on grasses, wheat, even more than maize, and Spodoptera cosmioides eridania is more related to cotton and soybean. That's why, even though you have this complex of species, fallworm worm is more, it is still restricted to grasses. However, the last crop season here in Brazil, it is occurring also in soybean a lot, and also feeding on both leaves and pods of soybean have those kind of damage, what is really a big concern. That's the publication that we made about this, about Spodoptera frugiperida, and about cosmioides eridania, talking about the different crop systems in biology, feed on different plants. If anyone would like to take a look more deeply on the papers, I can send you afterwards, no problem. When we see BP crops here in Brazil and Spodoptera management, it is important to analyze that we have a huge increase of BP soybean in Brazil, as you can see on this graph. However, BP soybean doesn't control Spodoptera because in Brazil so far, the BP soybean you have is with the protein Cry1AC, and this protein doesn't control any species of Spodoptera. And in maize, while you have some BP soybean with controlling the fallworm worm, we have already problems with resistance. That's why, for sure, Spodoptera is a big concern of the Brazilian research, and probably, as you can see here in this workshop, it's a concern all over the world, Africa and other countries as well. In soybean, you have an increase of the occurrence of Spodoptera. As you can see, the first chart, we have just 3% of the caterpillars that occurring in soybean was Spodoptera, and now last crop season, 22% is already Spodoptera, and we believe this percentage will be increasing. That's why we have a research area regarding Spodoptera here. This first part was just an introduction with the idea of show you guys the crop systems we work here in Brazil and the scenario where the research were carried out. Now, entering the biological control, really, I will talk about conservative biological control, how to preserve the natural biological control, and also talk about augmentative biological control. And this slide shows the importance of biological control inside the IPM program. Augmentative biological control will work as a tool, as insecticide, as pheromones, and any other kind of strategy you have to control pests. And of course, the natural biological control is one of the bases of IPM. And the idea is to highlight some ways to preserve biological control in the system. The easiest and maybe the most common way to preserve biological control is to use IPM with the idea of reducing the use of insecticides, chemical insecticides, the harmful ones. And how we can do that? Using economic thresholds. Apply insecticides only when necessary, when economically necessary. And when this time comes, I believe that the best way is to choose the products that are selected to the natural biological control, effective to the target pests, however, that brings less damage to the biological natural agents. And we have several. And what we're also trying our research in Brazil is to give some value to these natural biologics. And when we try to convince growers about the importance of using less chemical pesticides and choosing the most selective ones that sometimes is a little bit more expensive, we need to prove to those growers that biological control, natural biological control is important. If you get, for example, a Geocoris, a predator, it eats around 9 eggs of Anticarsis gematalis, a caterpillar common in Brazil per day. So one day you preserve is 9 caterpillars less in the field that we need to be worried with. We need to be using insecticide to control. So gnats, stink bug, a predator, also eats 21 eggs or 3 caterpillars per day. So preserve this natural biological control is 21 eggs less that you need to be worried with. So that's the same for Callida, for Calosoma. So when you give speech to growers, we try to show those numbers in order to show them the importance of preserving this natural biological control in the field, and try to convince them the importance of using selective pesticides. Doesn't matter if sometimes those selective pesticides are a little bit more expensive, but we have a lot of benefit using those selective pesticides. We have some trials with studying selectivity of pesticides here. My lab is focused on egg parasitoids, Trichogramma preciosum, Telenomus vermus, and also Telenomus podisi, Telenomus celionidae family, Telenomus vermus forest, Podoptera fugiterda, and Telenomus podisi for sheep bugs that are a really important problem for both maize and soybean have in Brazil. However, sometimes it's difficult because, as you can see here, different stages, they have different response to the pesticide, to the same pesticide. Sometimes the rates, if you use different rates, of course, you have a different response of the natural enemy, and also different species. You have, for example, Telenomus podisi that was selective, while the Trichogramma preciosum much more sensitive to pesticides, being extremely harmful. Number 4 is the most harmful one. Number 1 is the most selective one. Even herbicides and fungicides that sometimes we believe to be harmless to insects, we need to remember that they are chemicals and they impact natural enemies in the field, not just egg parasitoids, but if you think about fungicide, we need to remember that we have a lot of fungi. They are entomopathogen, that are beneficial to control especially caterpillars. So talking about biological control preservation, we cannot only think about insecticide, we need to think about fungicide, we need to talk about herbicide and other chemicals that you might need to apply. So that's why we need to apply those chemicals, how can I say, only when necessary, because they have some side effects on beneficial insects. In general, biological, if you, instead of use a synthetic pesticide, use a biological pesticide. An area that is increasing a lot to have fungi, BT, virus that are increasing a lot in Brazil. They are more selective than chemical insecticides, and of course, insecticides are more harmful than fungicides and herbicides. But as I mentioned, we cannot forget that they are also can be harmful, fungicides and herbicides, especially fungicides if you consider the beneficial fungi we might have in the field. About the chemicals in general, the insecticide growth regulators or diamides are more selective than pyrethroids and carbonates. So whenever possible, to replace pyrethroids and carbonates by insecticide growth regulator or diamides. It is positive regarding beneficial arthropods preservation in the field. Of course, efficacy, price, there are lots of things that must be seen, analyzed, but regarding to preservation of biological control in the field, of course, those chemicals are more selective than pyrethroids and carbonates. And even pyrethroids, carbonates, even biological should be applied when it's necessary. And it is when you have the economic thresholds that is a little bit below the economic injury level. And when the injury that occurs in the field will cause economic damage. And economic threshold, that's the time where the insecticide should be applied to avoid economic injury level being surpassed. We have done several studies about economic injury level to preserve, to have these numbers, to tell growers exactly when they should apply insecticides, when they should not apply. Here, it is sometimes you have artificial injuries, sometimes you have the natural infestation, and sometimes you have artificial.
Adney,
Go ahead.
Sorry for the interruption. Would you please raise your voice a little bit?
Okay, maybe it's my internet connection that is not.
I think if you just come close to, the PC or whatever you.
Okay. Better now?
Yeah, I think it's much better.
Okay. So here we show with the injury pods that soybean, that's the same for maize, that will be the same for any crop. That crop tolerates injury without reducing yields. So we need to establish those numbers to tell exactly growers when they need to control pests and when they need not to control. So here that's for soybean pods, for soybean flowers, because Podoptera unfortunately also damage some flowers in soybean, avoiding reducing yields. However, as you can see here, artificially removing 100% of the flowers, soybean was able to recover and to have the same yields. We have some papers published with the economic injury level, because I believe that's the only way to preserve biological control in the field. And what I can tell you that neither chemicals nor biological control alone will be able to control pests in general, especially asopolitical pests such as worm. So that's we need to combine all those strategies to have success in the management of those pests. And that's an example when a combination of strategies works together. We have the number of insecticide spray over the crop season. So in Paraná, the state where I live, the average of insecticide spray on soybeans is 3 to 4 times. But where we apply IPM, mainly sampling and just apply insecticides when economic thresholds are reached, we can reduce this number of insecticide application by half. So instead of 4, 2, instead of 3, 1.3. So without reducing yields, as you can see on the bottom of the table. And what is more important, so the average to spray insecticides in Paraná, it is 38, 48 days after sowing. In the areas where we sample, we spray just 30 days later. So 30 days without spraying insecticides, 30 days more without spraying insecticides, 30 days that will allow those biological control agents to work. And why, where you spray, where you sample, where you adopt IPM, is possible to take longer, to wait more to spray insecticides, mainly because growers in general, they have a tendency to overspray on the first appearance of pests, and also sometimes here, in this case more specifically, they will spray herbicide and fungicide sometimes for control weeds, and they most of the time they tend to mix insecticides to take advantage of the herbicide application. However, they reduce costs of the application, but they are wasting the insecticides because there is no need for that. And they are, of course, injuring all those biological control agents that are working for free in the field. So that's important to prove the growers that they can wait for the right time to spray insecticides, preserving the same yields, wasting more money, and of course preserving all those biological control agents. Talking about augmentative biological control for fall worm, I think we should talk about the egg parasitoids. That's the research we have here in Brazil. And 2 egg parasitoids we have studied so far, Trichogramma preciosa and Telenomus remus. Comparing both of them, Trichogramma is cheaper to be here in laboratory, mainly because you have factitious hosts. It's really easy to hear these biological control agents. And also they can be applying the field for different targets, different caterpillars, different Lepidoptera. And it is really important when you have multiple pest scenario. However, despite of Telenomus remus being more expensive because it uses eggs of Lepidoptera, it's not easy to hear Telenomus remus in a factitious host, even though possible. And consider that worm here in the laboratory is a little bit more labor intensive, is more expensive to have this parasitoid. However, it's much more efficient. We'll show you the data later, and more specific to work against comparing Telenomus haemus and trichogramma, you can see lifetime parasitism. Lifetime parasitism, the total number of eggs parasitized during the life of a female parasitoid, that is around 9 to 14 days. You can see that Telenomus haemus have a greater parasitism capacity compared to trichogramma. Also, in spite of being easier to hear trichogramma, it's a great challenge to use these egg parasitoids in the field, mainly because they have a short life, from 4 to 5 days. If you get laboratory results, it was 5 days, field results 4 days, and it only parasitized eggs of 1 day. So egg of 2 days, the parasitism was really reduced, and eggs of 3 days, the parasitism was 0, no parasitism at all. So the great challenge, you need to release the egg parasitoid and put together a parasitoid of no older than 5 days with eggs of 1 day old, so to have a really high parasitism. So that's a challenge for the timing, the correct timing for releasing these egg parasitoids in the field. Another challenge, when you release trichogramma, they will parasitize fall armyworm, but however, just the upper layer of the eggs. Since fall armyworm have egg masses with multiple layers, they will parasitize the upper layer, but the layers that are hidden, they will not be parasitized. So a lot of caterpillars will still hatch and damage plants. Telenomus haemus is different because they can dip inside the eggs and parasitize 100% of the egg masses. Doesn't matter if it's 3, 4, or 5 layers of eggs. As you can see here in this video, the parasitoids can really deep inside the eggs, find spaces until reaching the lower layer of the eggs, being able to parasitize 100% of the eggs. Also, they parasitize eggs of 1 day and also 2 days, what is good. The lifetime, the days, they will be parasitized. 4 or 5 days, they will be reaching 80% of the parasitism in the field. But it's a little bit easier to use Telenomus haemus in the field and more efficient against fall armyworm compared to trichogramma. Also, when we study the female age impact on its parasitism capacity, we see that keeping the female up to 10 days apart from eggs, host eggs, and after putting together, they keep the parasitism capacity. So Telenomus haemus female does not reabsorb its eggs. What happens with the other egg parasitoids, keeping parasitism potential. So it's really good if you release the parasitoid in absence of hosts and take some time for having hosts available in the field. However, since the use of Telenomus haemus, it is more expensive than the use of trichogramma in the field. One solution that you might have is the mixture of Telenomus and trichogramma, something that still needs to be studied. But since trichogramma is able to parasitize the upper layer and Telenomus remus able to parasitize all the layers, so if we release first trichogramma and after Telenomus, maybe Telenomus can be released in a small amount, just able to complement, to help the parasitism that was missed or was not efficient regarding trichogramma, mainly the lower layers of the egg masses. Something that needs to be studied yet, but a promising line of study for those who work with biological control. Dispersal of those parasitoids in the field is important. When we study the dispersal capacity of trichogramma, we realize that we need more than 100% of releasing points per hectare. That was really huge, and it make it really impossible to do manually. However, when you have drones that is a little bit cheaper today, we can use to release trichogramma in the field. The releasing of Telenomus remus is a little bit easier, requires less point. The dispersion capacity is much higher. It is important, as you can see here, these marked dots is where we recapture parasitoid that was released in the middle of the circle. And you can see here the wind direction. So it needs to be taken into consideration because, as you can see here, it impacts a lot the ability of the parasitoids to disperse in the fields. One way we're doing nowadays, it's, as you can see here, use drones. That's much less expensive nowadays, and you can precisely release the capsules with egg parasitoids. I'm going to the end of my presentation now, and in this end, I would like to point out some research that needs to be researched. Mass hearing, it is, we know how to mass hear the parasitoids, both trichogramma and Telenomus remus, but we need to establish some protocols for quality control, because we know that long-term mass hearing of those insects in the laboratory for later release might have some deterioration in the population, and for how long we can hear the parasitoid without introducing field insects, other quality control protocols still need to be developed, I guess. We are really good at sampling caterpillars, also evaluating insect injury in the field, mainly because we're used with chemical pesticides that will kill those caterpillars. However, if we talk about biological control, that is a little bit slower, the action, and also talking about egg parasitoids that do not kill the caterpillar, but the eggs that will, originate the caterpillar. So sampling is something that needs to be studied in order to determine when exactly those biological controls should be released in the field and how they should be released in the field. So there are researches that still needed to be carried out in order to really have it develop the biological control developed. And as one of my last slides, augmentative biological control is increasing in Brazil, all over the world. This is some data from Brazil. So what we expect to reach $237 million markets only with biological control. And despite of this great number, it is just 2% of the pesticide market. So the potential to increase, to use biological control, to replace old pesticides are huge. And of course, Telenomus remus is a good candidate, a great potential. Augmentative biological control needs to be used, but inside IPM. As I mentioned before, I don't believe chemical pesticides or biological control alone will be effective for high profitable crops such as corn, such as soybean. We need to use all those strategies, those tools together inside what we call IPM. That's the only way to really manage fallworm successfully. And of course, fallworm or other spodopterous species can be managed since IPM is used. Believing that a single technology, doesn't matter how powerful this technology is, will be enough to control the pest. I don't think that's the best way to do it. So I'm ending my presentation. That is I have a picture of my research unit here. I also have a video, but I don't think that's the case to play the video talking about my institution here. I think that's better to go for the questions if you have.
Oh yeah, thank you so much, Adi. I think you have showed too much work, and this has excited our mind and inspired us, to start developing our ideas to make like a collaboration or just make our own work. Thank you so much. So, and I think let's see what we have here. We have like Dr. Farid Harras. Doctor, I'm trying to unmute you. Adi?
Yes, I am here.
Yeah.
Thank you.
Dr. Farid Harras.
Harras. My name is Farid Harras, PhD, Emeritus Chief Researcher at Plant Protection Research Institute, ARC Egypt. Thank you, Dr. Bino, for your presentation on biocontrol. And you focused on egg parasitoid. Just in 2 minutes, I would like to comment on the evaluation of biological control by BT toxins. When we make evaluation of biological control by BT toxins, we have to keep in mind 2 points. First point, the insecticidal crystal protein of BT toxins is globular protein, which is marginally stable. That means the 3-dimensional structure of protein can be altered by number of agents and disrupt this structure, thus denaturing the protein. For example, high temperature from the sun during spraying in the field. And we know that the function of a protein, except when it is serving as food, is absolutely dependent on its 3-dimensional structure. So we need to increase stability of the three-dimensional structure of the insecticidal protein to enhance the toxicity. And I did it. And here is the title of my paper in 2009, molten globule structure of insecticidal crystal protein could be necessary to higher mortality in Spodoptera littoralis. Second point, recent studies demonstrated that the toxicity of Bt toxins is not only due to Bt toxins, Bt toxins, but also to the midgut bacteria of the insect, which leave the gut through pores made by Bt toxins and exit to the hemolymph, causing septicemia and the death of the insect. So silencing of the immune gene of insect would increase the insecticidal activity of Bt toxins, and that is by using the RNA interference. Thank you.
Thank you for your comments. Really important comments. And the only thing I have to add is that Bt is also more selective to pesticides. So I only focus on egg parasitoids because that is the research I have. So I would like to present my research here. But of course, Bt, both sprayable Bt and also Bt plants are important tools to be used against fall armyworm. And as I mentioned, I just believe using all those tools available, you'll be able to have a good control of the pests. Using single ones, I don't think will be effective for a long time. We'll have some questions here in the chat. I don't know the moderator.
Okay, let's take them. Yeah, let's take them one by one because there is other people raising hands here. So.
Okay, so they are asking about the meaning of ET, economic thresholds. There is when exactly they should apply insecticides. So that's why that's the only way to reduce insecticides in the field is to cut off the unnecessary sprays that sometimes we have because we don't sample. So sampling having the numbers, and those numbers are the economic thresholds when we should apply insecticides.
Yeah. Okay.
Can trichogramma be released before the infection appears as a precaution? That's important for biological control in general, especially when we talk about predator and egg parasitoids. They need hosts to survive because they need food. If they don't have food, and the food for the pest is the crop, but the food for the predator, the egg parasitoid, the natural biological control will be the pests. So if no food is available for them, they will die or they will migrate for other areas looking for pests. So we need to have pests to release biological control in general. The point is different from pesticides that we need to have a higher number of pests. When we use biological control, we need to have a smaller number of pests. So economic thresholds that we have available today in the field is most of them regarded to chemical pesticides. We need to develop economic thresholds for using biological control. That should not be the same as the ones for chemicals. That's important. There is a lot of things that need to be studied for those cases.
Okay, and I like your simplest way of explaining. I think you did it so clear. And we still have too much question here. I think Dr. Amal Zakaria. Dr. Amal Zakaria. Please open the mic and talk. Dr. Amal, are you here? Okay, Dr. Ibrahim.
سامعيني كده؟ الو.
ايوه اتفضل. دكتور
ايوه
أمل
اسمع حضرتك.
اتفضل.
حضرتك عايزه اسال بس بالنسبه للطفيلات استخدام المكافحه البيولوجيه بالنسبه للطفيل البراكون برافيكورنس استخدمته قبل كده على حشره دوت القصب الكبيره في المعمل وجابت معايا نتائج كويسه جدا. هل ممكن احنا نستخدمها برضو في دوت الحشد من ضمن المكافحه البيولوجيه؟ وان الحشره الطفيل بيضع البيض على اليرقه.
Adni, did you get the answer? Did you get the question? Sorry.
Could you translate for me, please?
Okay, I will try. I will try to because there is some people who especially translate for the other people, but I think I got the message. She used one of our colleagues used bracon. You know the bracon parasitoids. She used the bracon to control Sesamia critica. You know Sesamia critica. So is that like a valid for the fall armyworm, or she can also repeat the same protocol for the Sesamia to control or suppress the population of the fall armyworm?
We have some really braconid is really important natural biological control for different caterpillars, for different pests in general, if you get the genus. So yes, they are important for fall armyworm. We don't have a protocol to here in the lab for using this natural biological control, augmentative biological control as a pesticide to release that in the field. So we don't have protocols to hear the insect in the lab to release them afterwards. But it doesn't mean it is not important biological control. It just means that so far nobody is studying these biological control agents in a way to make possible easiest protocol to release them. We focus a lot on egg parasitoids because we focus on biological control to be solved there, augmentative biological control. And egg parasitoid is before any injury occurs. Braconid will work on caterpillars. Egg parasitoid will be work on eggs. So if you have any problems that the biological control doesn't work, you don't have injury. We still have time to apply other biological control or other pesticides, even chemical. So that's why we study a lot, we focus a lot on egg parasitoids. But as I mentioned, it doesn't mean bracon, for example, is not important. The opposite is really important biological control agent.
Okay, I think there is other question here.
Yeah, okay. Is there any competition between Telenomos Cryptogramma and Telenomos? Yes, they will compete for eggs. However, the idea when I talk about releasing both of them is most of the time, at least in Brazil, even in maize, where our worm is the major Lepidoptera, we have the other Lepidopteras that occur together. So in maize, for example, have a Lycoverpa. In soybean, you have different other species. So releasing Telenomos is really good for Spodoptera, but we still have some other caterpillars. So if you release a mix of the egg parasitoids, Yeah, we might have some competition, but the trichogramma will be able to prioritize all the species of Lepidoptera most of the time. We'll prioritize the upper eggs of the egg masses of Lepidoptera, and Telenomus, that is a more expensive parasite to be used commercially, you be used just for to finalize the biological control in those inner egg masses. So that's why, of course, we need to study this a lot. There's a first paper that was published, but there is a potential that could be using both parasites together.
Okay, Adney. Also, you did mention, in in your presentation, conservation, biological control, and also I've seen green bridge. Okay, what that mean, green bridge? Is it like seasonal flowering border or any kind of flourish in the environment or something like that, or just?
No, green bridge will try to. When you were like giving an overview of the agriculture we have in Brazil, green bridge means the constant presence of crops in the field, because we don't have, different from North America, United States, mainly where you have the winter, the snow that comes and pretty much will kill most of the insects. We have here, we have summer all over the year, and you have crops in the fields all over the year. So that's called green bridge. We also always have a green crop offering food for pests, for insects. And of course, it will benefit mainly the polyphagous ones who can be the insects that are able to feed in different crops. What is the case of our fall armyworm that feeds on different crops?
Yeah, I've asked you especially because the conservation biological control. It's I think the ultimate solution for the environment. I know it's not that quick, it's not that rapid action, but it's a sustainable solution because all the augmentation biological control or classical biological control, all of these approaches take long time, take a while until the action starts to begin. So that's why I want to ask about that green bridge. I think it's a good question. Let's move on to other question. I think Mahmoud. Mahmoud. Yeah.
ايوه.
Yeah, Mahmoud. Okay, Mahmoud.
السلام عليكم. هل تسمعني؟
نعم أسمعك بوضوح، تفضل.
هل تسمعني؟
أسمعك لكن في دوشة كتير جنبك.
الو. هل هناك تعاون دولي في مجال حشرة الحشد الخريفية؟ هناك تعاون دولي في مجال مكافحة حشرة الحشد الخريفية على قرار
I don't know, Adini, did you get the question?
No, can you repeat in English for me, please?
No, would you repeat again? Oh yeah, I think we lost that.
Hello, this is me, Mansour.
Oh, Mansour, okay, go.
Yes, I would help you to interpret and translate the question. He's asking about if there is any international cooperation to fight back the fall worm army.
Anthony, did you get it?
Okay. Yeah, if there is international cooperation to fight back the fall worm. Yes, there is. I don't know how effective it is. We know that CABI has a good international collaboration in Africa, helping growers to fight fall armyworm. I have some collaboration with CABI. I don't know much about other international collaboration, but we are, as entomologists here in Brazil, we are, how can I say, here to help you with anything you can regarding to our experience that is mostly focused on the major crops, soybean, maize, cotton that you have here in Brazil.
Okay, Adini, I think Dr. Ibrahim has
Yes.
been waiting too much time, so he is
Thank
the
you,
line.
thank you, Bueno. Thank you very much. It was really very interesting. Presentation. First, I want to comment to Dr. Emel. She asked about the Bracon brevicorni. Bracon brevicorni is working on fall armyworm. There is a paper published by Gosh and Etel 2020. She can follow this paper. I can send her the paper if she wants. Anyway, this is first one.
Yeah.
I have learned a lot from Improper publications. Really, Improper, it was our first source of information for fall armyworm and other, you mentioned Silva. I have learned from Silva. I have learned from you and the biological control. There's many publications.
Yeah. Exactly, yeah.
In your, what's interesting for me in your, I'm not into biological control interest, but the impact of pesticide on biological enemies. Really, I don't know if that field result or this is, laboratory result, because I have seen the effectiveness of many. Okay, fortunately that the insect growth regulator, they are safe for the both Trichogramma and Telenomus. But for example, the spinosad, which is being used expensively, it's still, effective, the high effective or bad negative effective on Telenomus ramus, I think. No, the Trichogramma pretiosum. And
yeah.
Yes, please go ahead.
Spinosa is a really safe, how can I say, pesticide. It is even considered organic. For in some parts of the world, you have some formulation of Spinosa organic Spinosa, because Spinosa is produced by fermentation of bacteria. So that's a product produced by fermentation by bacteria. So it is really safe for humans. However, they have some problems with Hymenopterans. So I present the results of Hymenopterans, egg parasitoids, Telenomus, Trichogramma. So Spinosa has some problems with the Hymenopterans. It is, though, really selective to other natural biological control agents, predators such as beetles and other important ones. They are selective. So that's the problem we have with selectivity, because we are specific to one species of natural enemy. So it is the most important species in the field. In the field, we usually have many species. That's why the best way to really have preservation, it is, of course, to use APM, to use economic threshold, to avoid the use of insecticides, because even the selective ones will have some harm to the
have a negative impact, exactly. Yeah.
Yeah. So that's why. Of course, we might have some generalization. If you get diamides, spinosines, like such as the spinosad, and mainly the insecticide growth regulator, they will be more selective, cause less infected compared to pyrethroids, carbamates, in general. But the best way is always to use them based on economic thresholds. Never overuse insecticides. Even biological control agents can be, if you overuse, can have a negative impact.
Exactly. Dr. Ibrahim, are you done? Because
Yes,
Dr. Magid on the line.
Yeah. I think Rob he mentioned something in the chat. You can see it.
Rob, we also have Dr. Magid. So if are you done, we will take.
Yeah. Thank you very much. Thank you.
Okay, Dr. Magid, you can talk.
Thank you for the question.
It's more a comment more than a question. Thank you for this very good presentation. I think it's covered a lot of biological control aspects, and for sure there is no doubt that Imprampa is one of the excellent centers in terms of fighting fall armyworm and other pests and diseases, and there is a lot of international cooperation. And I think what is Rob shared shared in the chat box is one initiative for fall armyworm research collaboration, and I think it's an international portal. Anyone can post his work on this, and it's very useful if you want to track the research on fall armyworm. And it's not only for Africa or Latin America or Asia, it's an international one. And also in responding to Mr. Mahmoud about is there is international cooperation, actually there is many initiatives for fighting fall armyworm. In Africa, there is IITA and I think ITTA, and I think they already the first institute to discover fall armyworm in Africa. And then later on, ECP is offering a lot of support to African country. CABI, as Dr. Adeni mentioned, FAO is leading a global action in fall armyworm. So they are trying to take the lead and coordinate all efforts to have some impacts for managing fall armyworm at the field level. And I think it's a very long story, but just to mention that Egypt is one of the 8 demonstration countries, and it represents the NENA region. So North Africa and Near East and North Africa region. And of course, Egypt has a good infrastructure and capacity. And hopefully within the next 2 years, we'll see more experiment and more collaboration between the countries in the region, as well as between Egypt and other regions and other countries. So that's all, and thanks again for this opportunity. Back to you, Mr. Coordinator.
Okay. Thank you, Dr. Magid, for that question. And Adeni, do you have any comments about Dr. Magid?
No, that's thank you for the comments. Really important comments and important for all of this.
Okay, let's see if we still have.
We'll have some. There's a question here in the chat. When is the best time to release the kite program? Early in the morning or before sunset? Well, it depends on if you are releasing pupa of the parasitoid or if you are releasing the adult. The adult, it is important to release early in the morning because the trichogramma does not parasitize during the night. However, during the night, it is when you have the lowest temperature. So if you are releasing pupa, so releasing during the night can be an option because you have the adults emerging early in the morning. So the focus is to have the adults during the day. They need light to parasitize.
Okay, thank you so much, Adeni, from Brazil. And anyone have any other questions? Because now I can control the mic right now. So okay, I think that's it. Really appreciate it, Adeni. Really well developed lecture, and me personally, I learned a lot from you, and We look forward to collaborate together forever. And thank you so much.
Thank you for the opportunity. I really didn't get in deep in any part of my presentation because I think the idea was just to touch different subjects.
Exactly.
And of course, I am here available for anyone who wants to discuss, to develop a further collaboration. My contact is in the slide. So
sure,
please feel free
okay.
to contact me. I thank you very much for the opportunity to be here.
You're welcome.
With you guys. And I hope I have reached your demand, your expectations.
Exactly. Thank you so much, Adam. See you.
Bye-bye.
Okay, bye-bye. Okay, guys, I think by that, I think we came to the end of our workshop. And we're looking forward to Dr. Noha. Are you here? Says Dr. Noha, are you here?
خلاص فتح.
خلاص. السلام عليكم ورحمة الله وبركاته. تم بحمد الله الانتهاء العمل الدولية إستراتيجيات 5 و6 البرازيل كينيا وزامبيا. كما أتقدم بعظيم شكري إلى هذا العدد الضخم الغير مسبوق من المشاركين والحضور من الجامعات والمراكز البحثية من مصر والعالم العربي والعديد من دول العالم المختلفة. وقد تناولت الورشة العديد من المشاكل التي تسبب هذه الآفة للبيئة المصرية والعالمية ودورها في التقليل من الدخل القومي العالمي وتأثيرها على الأمن الغذائي. وقام المحاضرين بعرض كل ما يتعلق بهذه الآفة خلال 600 دقيقة في يومي الورشة. وأشكركم مرة أخرى وأتمنى لكم التوفيق والنجاح الدائم. والآن فليتفضل الأستاذ الدكتور أحمد عبد المجيد مدير معهد بحوث وقاية النباتات بختام الورشة.
شكرا دكتورة نوح. بسم الله الرحمن الرحيم. في البداية أود أن أشكر جميع السادة العلماء المحاضرين كل باسمه من الولايات المتحدة الأمريكية والبرازيل والصين والهند وزامبيا وكينيا على مساهمتهم القيمة بفعاليات الورشة. كما أشكر الأستاذ الدكتور إبراهيم الجبوري رئيس الجمعية العربية لوقاية النباتات والأستاذ الدكتور ماجد الكحكي الصديق العزيز والأستاذ الدكتور عبد الفتاح مبروك وجميع أساتذتي وزملائي بمعهد بحوث وقاية النباتات وكل المشاركين من الدول العربية والصديقة. كما أشكر الفريق القائم على تنفيذ هذه الفعالية. السادة الحضور الكرام على جميع المنصات، لقد سعدنا بهذا التواجد الاستثنائي وهذا الزخم الذي أحدثته الفعالية، ودائما نتوق إلى تواصلكم المستمر ومشاركاتكم التي تثري جلساتنا. واستشعارا منا بالمسؤولية كان لابد من مواجهة تلك الأزمة الوليدة التي يواجهها العالم منذ عدة سنوات. علما أن الآفة موطنها الأصلي ومتواجدة في الأمريكتين ولها مشاكلها هناك ولها أساليبهم في السيطرة عليها، ولكن بالنسبة للعالم القديم زي ما بيقولوا أفريقيا وآسيا أصبحت بالنسبة لنا آفة غازية جديدة. وتلك الآفة تواجدت في مصر ولم نقف مكتوف الأيدي منذ رصد تلك الآفة، بل على العكس قبل دخولها إلى مصر بعام ونصف كنا نعمل على هذا الملف ونتابع التطورات والآليات طانة وقصرها على نطاق ضيق وحصرها في هذا النطاق ولكنها العالمية، ونحاول السيطرة عليها بقدر الإمكان. وبقراءة الوضع قراءة مستفيضة نجد أنه لن يجدى معها الحلول التقليدية المتاحة، وهي استخدام المبيدات الكيميائية كحل مستدام لتأثيرها السلبي على الأعداء الحيوية المتواجدة بشكل طبيعي في البيئة، مما يخل بالتوازن البيئي، وقد يأتي بنتائج عكسية غير مرجوة لا يحمد عقباها. من هنا كان لابد من التعاون الدولي مع الدول التي لها سابقة نجاح في اجتياز هذه الأزمة لتبادل الخبرات العلمية والوقوف إلى بعض الحلول سيتقوم الأول الخروج ببرنامج للمكافحة المستدامة لدودة الحشد الخريفية من هذه الورشة يمكن تطبيقها في مصر وتطبيقها إقليميا وعالميا. الحقيقة احنا قعدنا خلال اليومين دول نحاول ندون التوصيات، وجدنا أن التوصيات بالفعل كبيرة. نرجو ان احنا تطبيقيه امنه وفعاله في منطقتنا كاقليم وفي العالم كله باذن الله. اعتقد ان احنا جمعنا بعض التوصيات من بعض الاساتذه الكرام المتابعين للورشه، ولكن اعتقد انه يمكن ان احنا وتسال للاستاذ الدكتور نوع عبد الجليل وكيل معهد البحوث لادراجها ضمن التوصيات. ولكن اعتقد ان احنا وجدنا ان هناك بعض النقاط المتفقين عليها، منها ان احنا يجب ان نعمل على الاستفاده من الدراسات الجينيه في تقليل صفه المقاومه والفعل للمبيدات في الآفة من المحاضرات الاولى. ايضا اهميه دراسه سلوك الآفة على المحصول والوقوف على نقاط الضعف التي يمكن التعامل معها. ايضا رصد دودة الحشد الخريفية ومتابعتها من خلال وسائل الرصد من المصايد الفيرومونيه، ولكن احنا خلال الفتره اللي فاتت كان معظم الفيرومونات اللي كنا بنشتغل عليها كانت بتجيب لنا آفات اخرى، فكانت غير متخصصه. فنرجو ان يكون ان شاء الله في المرحله القادمه ان احنا نعمل على الوصول الى فيرومونات شديده التخصص على دودة الحشد الخريفية. ايضا يجب ان احنا نجري اجراءات حازمه لتدابير فعاله عن طريق اتباع الاسلوب العلمي في دراسه وتقدير خطر الآفة. معظم الدول بتتعامل مع الآفة قبل اجراء دراسات على دراسه خطوط الآفة، وده من الخطأ الكبير. استخدام المبيدات الحيويه ضد دودة الحشد الخريفية هو خيار آمن وفعال ومثبت نجاحه في التحكم على هذه الآفة، حتى لو أعطتنا نتائج كفاءة أقل نوعا ما من المبيدات التقليدية، فإن احنا يجب إن احنا نحقق التوازن ما بين السيطرة وما بين الإخلال بالتوازن البيئي أو التلوث البيئي في محاصيلنا الزراعية اللي ممكن في النهاية تصل إلينا تسبب لنا مشاكل كمتبقيات مبيدات في المادة الغذائية. أيضا يجب أن احنا نكثف من التدريب الإرشادي للمزارع والمدارس الحقلية اللي ساعدنا في مصر هنا، اللي هو إزاي أن احنا خلال السنة ونص اللي قبل دخول الآفة إزاي أن احنا نوصل بالمعلومة ونعرف المزارع. وصلنا المعلومة من الباحث في معمله في معهد بحوث وقاية النباتات في قسم التصنيف اللي بيقدر ان هو يوصف ويعرف الآفة اليرقة، ان احنا ازاي ان احنا نوصل هذه المعرفة للمهندس والمرشد، بل على العكس ان احنا قدرنا ان احنا نوصل للمزارع الصغير ان هو يتعرف على الآفة بالظواهر حتى المورفولوجية. احنا لم نسجلها في مصر ولم تشكل بشكل رسمي الا بعد اجراءات العلميه لما تم التعريف بالتعاون مع الفاو عن طريق الكابي، وقدرنا ان احنا نصنفها من الناحيه الدي ان ايه. ولكن ان احنا وصلنا حاليا لمرحله ان المزارع البسيط يقدر ان هو يتعرف عن هل الآفة دي دخلت في ارضه ولا لا. ايضا استخدام وسائل المكافحه البيولوجيه لدودة الحشد الخريفية باستخدام الاعداء الحيويه داخل البيئه المحلية. أيضا التوصية بتقييم أنواع طفيليات ليست التايكوجراما. ثبت لنا ان كل التايكوجراما الموجوده لها مشاكلها في عمليه التطبيق وبتعطي نتائج يعتبر مش مرضيه. طب هل هناك في انواع محليه ذات كفاءه؟ ان احنا لازم ان احنا نقيم. احنا بالفعل في الفتره اللي فاتت وجدنا ان احنا كنا نعتقد ان عندنا نوع او اثنين، انما وجدنا عندنا انواع ممكن تقييمها، الى جانب ان احنا عندنا اعداء حيويه وطفيليات يجب ان احنا نقيمها، يجب ان احنا نحافظ عليها. ايضا ان احنا بالاضافه للبيولوجي الموجود بالبيئه، في النهايه يجب ان يلمس يعني من خلال حتى لو في اي خطوات بين الدول وبعضها او المنظمات الدوليه. ليه؟ لان احنا يجب ان احنا نعمل على، لا نعمل في داخل الاوقه في المكاتب، لا نعمل في قاعات الورش. يجب ان احنا نصل في النهايه المستهدف بتاعنا هو المزارع الصغير اللي عنده قيراط واثنين وبيعتمد عليهم في غذائه وفي دخله، وفي حاله لما يتم القضاء على هذا المحصول بتاعه في النهايه نكلمه ونقول له على التعاون الدولي او التعاون بين المنظمات والمصر، لا يلمس ذلك. يجب ان لا نعمل على حقول ارشاديه فقط، يجب ان نعمل بكثافه التوعيه، المدارس الحقليه، ننزل نشتغل على الارض، ما نتكلمش في اجتماعات واروقه والآفة منتشره والمزارع متضرر. أنا مش مع التقارير العلمية، التقارير اللي نقول كله تمام. أنا مش مع إن إحنا التعاون ونعلن في الميديا. أنا عايزين نوصل للمزارع، نشتغل على الأرض، ما أقولش إن كله تمام والحركة الآفة منتشرة. أرجو أن نكون جميعا من باحثين في معهد بحوث وقاية النباتات حصلوا على قدر من المعلومات العلمية المتنوعة. نتمنى من الله أن يحمي مصر والعالم من كافة الآفات وكافة الأمراض، ويكفينا كوفيد 19. فأرجو كمان أن احنا لا نصاب في غذائنا، وأتمنى للجميع الخير وجميع المشاركين، وأشكر حضراتكم مرة تانية، ونلتقي إن شاء الله في فعاليات أخرى. معهد بحوث وقاية النباتات بينظمها بشكل دوري سواء حضورا أو افتراضيا. أشكر مرة تانية أساتذتي وزملائي وجميع المشاركين والحضور، والسلام عليكم ورحمة الله وبركاته. شكرا.
يقعد اللي في فستان ايه هاي ما يتكلموا ما كانش يعني
لأنه إذا خاصة الأطفال
ايه هو في ايه ما يعملوا